Hello, good evening, everyone. Welcome to the fourth session on PLS SEM in R. Yes, so far we have seen the basics of PLS SEM. Yes, and if you remember in the previous session last week, we talked about a simple model and we use that corporate reputation data which is there in the seminar package and we tested a model in order to understand the direct effect between the constructs. Yes, so today is the fourth day and we are going to talk about mediation. Yes, okay, so I hope my screen is visible to all of you. Just respond if my screen is visible to all
Yes,
of you.
sir.
Okay, so let us start with the basics of mediation. What is mediation, and when should a researcher conceptualize a mediation model? Yes, and what are the issues in mediation, and how a mediation model can be tested? Yes, okay. And as I said that our studio is capable of handling every sort of model, be it a mediation model, be it a moderation model, or let's say you want to perform a multi-group analysis, or let's say even if you have some complex model. So if you remember in SPSS, there is a plugin which is known as process macro. Hope the screen is, hope the session is being recorded. Yes. Can you see that recording option, all of you?
Yes, sir. It is going on.
Okay. So in SPSS, there is a plugin which is known as process macro, and it is given by Professor Hayes. So Professor Hayes has proposed around 70 models in his book. So that's a wonderful book that you should read. So even all the models which are there in the process macro, that can be easily tested in PLS SEM. So PLS SEM, the beauty of PLS SEM is that it is capable of handling or testing complex models. So you come across papers where people often cite that my model was very complex and that's why I'm using PLS SEM instead of CB SEM. Yes, okay. So today is the session. Again, we are going to do hands-on practice on our studio, and definitely day two syntax has been uploaded in the R syntax file. I request all of you to download that R syntax and store it in a place where you want, where you can easily access it. Yes. So today let's understand the concept of mediation. The concept of mediation. Yes. Okay. So now to explain you this particular concept, let's say there is one construct called, now today I'm going to test a model again. So let's say there is one construct called SIC. Now when I say SIC, it stands for self-influencer connection. Okay, so let me go very simply. So today I'm going to take a model from this particular textbook, which is PLS SEM using R. So here you can see a model. So SIC is self-influencer connection. See, we all see YouTube, or for that matter, we use Instagram, we use Facebook, and there are influencers which are very popular these days. So normally consumers or people identify themselves with some or the other influencer. So SIC stands for self-influencer connection. Means if I'm seeing an influencer, let's say there is an influencer, am I able to connect with that influencer? Yes, so we people have a connection with certain influencer. So what this model says, that if you connect yourself with some influencer, yes, there will be perceived liking. There will be perceived liking. Yes. And if there is perceived liking, yes, you are going to, you will develop purchase intention. Purchase intention means you will develop the tendency to go and buy the product. Again, purchase intention is a feeling where you feel like buying a particular product. Yes, okay. So if you see this model, now again, this is a marketing example. Now, so far in all my sessions, I used to give a lot of examples from my own PhD thesis, because my PhD is into management and particularly into organizational behavior. But here in this session, I'm just slightly taking a different route. And as I said, let me take a very different example from marketing. Again, people who are from strategy, people who are from marketing, they can connect very easily to this particular model. So again, I'm saying self-influencer connection is SIC. So if you develop connection, or if you feel that you are very close to certain influencer, you are going to develop personal liking. Yes, and this personal liking is going to foster purchase intention. So now, yes. So now, so now mute yourself. So now mute yourself. So now the model that you see before you. So there is one direct effect. So when I say self-influencer connection, it leads to purchase intention. Yes. So this is a direct effect. This is a direct effect. Yes. So if you remember in the previous session, we only tested for the direct effect. We didn't touch mediation. Now here you see there is one construct which is known as perceived liking. So, so when I say perceived liking, it means there is a new variable which has come into existence. And so there is one path which flows from, so there is one path which goes from SIC to PI, but there is one path which also goes to PI, purchase intention, from perceived liking. So there is one direct effect and there is one indirect effect. So when I say indirect effect, it means SIC leads to perceived liking, and this perceived liking leads to purchase intention. So when there is another variable in the model, or let's say there is another construct in the model which affects the relationship between the two variables, that is SIC and PI, we say there is an indirect effect. Yes, there is an indirect effect. Yes. Now, when you talk about mediation, actually you are testing for the indirect effects. Indirect effects. Yes. Okay. Whenever you go for mediation, you actually check the indirect effect. Okay. So there is a direct path which goes from SIC to PI, but there is also a path which goes to PI from pursued liking. So here in this particular model, you are testing the mediation of PL. Yes. What I will be testing? The mediation of PL in the relationship of in the relationship of SIC and PI. Yes. So SIC and PI. Now please understand, my friends. Now, when I talk about, just a second, or let's say when I talk about mediation, mediation always answers the question how. Mediation answers the question how. So how question means, rather, so there is a direct path and there is also a path which goes from the mediator. So mediator always answers the question how. And also you will come across papers where whenever authors conceptualize a particular construct as a mediation, they try to explain the underlying process. Yes, they try to explain the, just a second, they also try to explain the underlying process. So mediation, it also explains the underlying process. So now, whenever you bring any new construct into between two constructs, yes, you are actually contributing to the theory. Yes, okay. So now we are going to take this example, but let me again give you a very good example. Yes, okay. Now let's say uh, there is a term called notoriety. Now normally I talk about this particular model which I have conceptualized according to my own understanding, and this is a theoretical model. Now when I say a theoretical model, you won't find this model in any established papers. Now I say that notoriety leads to success. So success. What is notoriety? Notoriety means, let's say if somebody is mischievous. Now here I'm talking about notoriety in your formative years. Now just reflect back that when you were small, let's say when you were in your school, how notorious you were. So what I'm saying, that if you are notorious in your formative years, you are bound to be successful in the later part of your life. Yes. Now again, this is a longitudinal data. Notoriety has to be measured from a very back angle, and success has to be measured in the present terms. So notoriety leads to success. So let's say somebody has given a theory that notoriety leads to success. Now somebody say, no, notoriety leads to success, it is fine, but there is something which is missing in this model. Yes, somebody would say, no, notoriety simply can't predict success. There is one element called creativity which is missing. There is one thing, creativity, which is missing. So somebody said, no, okay, it is fine that notoriety leads to success. I agree. But don't you feel that notorious people are creative and this creativity leads to success? So somebody came and brought one more construct into the model called creativity. Now, so there is one path from notoriety to success. So there is one path which also will also go from notoriety to creativity and from creativity to success. Now, whenever you see one mediation in a model, now here you see before you have two models. So one is SIC, PL and PI, and second is notoriety, creativity, and success. Now, in both the models, there is one construct which is conceptualized as a mediation. So whenever you see one construct conceptualized as a mediation, we call it a simple mediation. So both the models that you see before you, it is a case of a simple mediation. It is a case of a simple mediation. It is a case of a simple mediation. So both the model, this model and this model, they both are simple mediation. Yes. Now let us extend this notoriety success model. Okay. So let me use a different marker. Now somebody said, okay, you say that notoriety leads to success and creativity was something missing. So you bought creativity, you collected data on creativity, you tested the model and you propose a theory that, okay, notoriety leads to success, creativity was missing. So notorious people are creative and this creativity leads them to success. Now some new person came and say, no, something is still missing in this model. A new person is coming and saying something is still missing in the model. So the new person says, okay, notoriety leads to creativity and creativity leads to success. That is fine. But don't you think that notorious people are more risk taking in life? That notorious people are more risk taking in life. So a new researcher came and he extended this model. I think Afreen or some other people were talking about, Kiran was talking about, or Abhishek was talking about that, sir, I have taken one theory, established theory, maybe a UTAT theory or maybe a social identity theory. So there were already some constructs, so I brought a new constructs. So whenever you bring a construct, you really need to have some backing to it or some strong logic to it as to why you are bringing that particular construct into the existing theory or the existing model. Now here there is a person who will say, I agree to this particular model that notoriety and creativity, success, they are interlinked. But there is one more construct which is missing. So a new researcher came and he brought risk taking. Now he will say notoriety also facilitates risk taking and this risk taking causes success. So now here you see in this particular model, there are two mediators. So first mediator is creativity and second mediator is risk taking. So whenever you have two mediators in your model of this sort, the diagram that you see notoriety success, this is known as a parallel mediation. This is known as a parallel mediation. Yes. Dr. Love, hope you're understanding. Dr. Love, hope you're understanding. Yes.
Yes, sir.
Okay. So now here you can see before you that first this self-influencer connection, perceived liking and PI. This is a case of a simple mediation. And now here you have a different model where there are two mediators in the model and they are parallel to each other. So creativity and risk taking, they are parallel to each other in a geometric sense. So you call them that this is the case of a parallel mediation. Yes. Now, okay. So now please understand there are basically three kinds of mediation. One is simple mediation and one is parallel mediation and third is your serial mediation. Now somebody would say, okay, notoriety leads to success and okay, somebody would go and say, just a second, let me put it in a very nice way so that everybody understands how this moderation or how this mediation model basically is conceptualized. So somebody said, okay, notoriety leads to, let's say, risk taking, and risk taking leads to creativity, and then creativity leads to success. So somebody went and conceptualized the above model in this particular way, collected the data and presented the finding before all of us. Yes, okay. Now, before you friends, you see three model. So first model is simple mediation. There is one mediation. Second model, there are two mediation and they are opposite to each other, but there is no arrow which is going from creativity to risk taking. But there is one more model where there are two mediations, where here you can see that there are two mediations. So between the direct path of notoriety and success, there are two mediators. There are two mediators and they are sequentially connected. They are sequentially connected. Yes. So now the third model that you see before you, it is a case of a serial or sequential mediation. It is a case of a serial or sequential mediation. Please note this. So when I say mediation, either you will conceptualize a simple mediation or a sequential mediation or a parallel mediation. Now, I was talking about Professor Hayes, his model, and process macro is there. And by the way, if time permits, maybe I'll definitely conduct one workshop on mediation, moderation, and conditional process analysis. Yes, definitely by either May, June, July, whatever it is. I will keep you updated, and we'll develop a very good relationship with all of you for a long term perspective. Yes, okay. And it's a research community. We should always believe in sharing, learning, and knowing from each other. Okay. Now, if you read Professor Hayes' process macro and all the template that he has given, and by the way, he has also come out with an interesting book. Yes. So if you talk about Professor Hayes, he also talks about one more model. So he will say A leads to B, B leads to C, C leads to D, and D leads to E. So he talks about three mediators. So here you see there is one direct effect. So there is a direct effect from A to E. Yes. And there is also an indirect effect where there are three mediators in the model. So here you see, here there are three mediators in the model. Now, again, this is an example of your serial or sequential mediation. Sequential mediation. Yes. Okay. Okay. Now, all of you just pay attention. So now let me take a very simple mediation model. By the way, we are going to test a parallel mediation in today's class using a formative construct. So in the previous session, we took all the constructs which were measured reflectively. So today we are going to take one particular construct which is measured formatively. So if you are measuring a construct formatively, so how to do convergent validity of that particular construct, we are definitely going to see. So let me give you a simple model. Let's say I am saying A is my independent variable and C is my dependent variable, or A is my endogenous and sorry, A is my exogenous construct and C is my endogenous construct. And so there is a direct path which goes from A to C. Now somebody gone ahead and conceptualized M as the mediator, M as the mediator. So he connected this dot also, this dot also. Now, if you read standard textbook, they call this relation, the path from A to M is A, and the path from M to C is B, and this path is known as C dash. This path is known as C dash. So now, if you want to write an equation, how would you write an equation? You put it this way, that mediation is equal to C is equal to C dash plus A into B, A into B. So A into B is nothing but A, the path coefficients of A and M and the path coefficients of M and C. Yes. So this path, this A and B, this is known as your indirect effect. The product of the product of path A and M and the path M and C. When I say product, it means you are multiplying. Yes. So this is known as indirect effect. If in your analysis, if this path comes out to be significant, let's say if the p value is less than, or let's say if the p value is less than 0.05, we say that there is a mediation. So if the p is less than 0.05, we say there is a mediation. So for mediation to happen, this indirect path When I say indirect path, it means the product of A and B. The product of A and B should be significant. Yes, hope it makes sense. Now, let us do one thing. Now, let us go and test a mediation model. Now, before I proceed, so I have taken this particular example from the seminar reference material which has been provided to you. Yes. Now, all of you pay attention. All of you pay attention. So, there is one variable which is known as SIC. Now, this is known as self-influencer connect. Yes. Okay. I'll show you here. So, these are some of the measurements, and let me remove this. Okay. So, now here you can see, friends, that uh, self-influencer connection, SIC. So you ask certain questions to the respondent. Yes. And here you can see there is one global item. There is one global item. So my personality and the personality of the influencer relate to one another. Yes. Okay. So now this self-influencer connection, it is conceptualized, or rather it is measured as a formatively measured construct. Now, go back to the first session. We did talk about reflective constructs and formative constructs. So when I say reflective constructs, yes, it is the construct which is causing the indicator. And when I say formatively measured construct or formative constructs, it is the indicator that causes the construct. Now, please understand, it is very easy to drop items in a reflective measured construct. Yes, let's say if some of the items, let's say if some of the items in reflective measured constructs have loadings lower than the recommended threshold, people go and drop it and rerun the analysis, and they find this convergent validity and discriminant validity improving. Yes, but dropping a item in a formatively measured construct, it is not easy. Please remember this. Why? Because it is the indicator that is causing the constructs. So when you, let's say, if the indicator is causing the construct, and if you drop the indicator, then the validity of that particular construct will be challenged. Now, let's say if you are computing human development index, or let's say you are computing gross domestic product, or let's say any of the concept. So it is not that easy to drop a particular indicator or particular item from a reflective measured construct. That's why the convergent validity of formatively measured construct is slightly different, and it's rigorous also. So here, if you see, this is the model which is given in the book, for which syntax is not given. Yes, by the way, data is there in the seminar package itself. So the model that you see before you, yes, it is SIC leads to perceived liking, and SIC also leads to perceived quality. And let's say if and this leads to purchase intention. So now when I will be testing this model, friends, I will not be taking this particular construct, WTP, or willingness to pay, how much you are willing to pay. I'm not going to focus on this. Now I'm going to focus on the four constructs, and I'm going to conceptualize it as a parallel mediation. Hope so far this particular doubt is, or hope so far this particular issue is understood by all of you. So I'm going to take four construct. Yes, I'm going to test this particular model. I'm going to test it. Yes, and I'm going to ignore this willingness to pay. Yes, let's keep the model simple. By the way, there is a term which is known as model parsimony. Now, when I say model parsimony, it means that don't complicate your models, or rather uh, choose your constructs wisely. Don't include as many constructs as you like it. Yes, and make your model a model parsimonious. When I say parsimonious, use less variables and try to explain many. See, model parsimony does not mean not to include variables and be selective. No, you have to do your thorough literature review, understand the nomological validity, and bring those constructs which have a very important say in the explanation of the endogenous construct. Yes, okay. So now we are going to focus on this particular model. By the way, uh, this SIC, if you focus on SIC, see it is the indicators. It is the indicators which are causing the construct. See the head of the arrow. The head of the arrow is from the manifest variable or indicators to the construct. Now, if you focus on PL, yes, it is the arrow which is or the arrow is from construct to the indicator. So PL, PI, and PQ, all these three constructs are reflectively measured, but there is one construct which is measured formatively. Yes, and this is a case of a parallel mediation because PL and PQ, they are opposite to each other. Geometrically, they are opposite to each other. This is what we have learned in our school days geometry. Two things, if they are opposite to each other, we call it as they are parallel to each other. Okay. So, okay. Is there a question? Is there a question? As somebody has put something in chat. Okay. Can we get this paper? Acha, is it today's chat? Acha, no, no, no. Any question? No, there are no questions. Okay. So now, friends, all of you pay attention. So today I'll not focus much on the syntax because syntax part you can definitely go and you can write it on your own. Because anyway, we have to cover a big journey in these 3 days. Yes. Okay. So this was the day one syntax. Let me remove this file. And day two syntax. Day two syntax, it is there. I have also added it some pointers here and there or rewritten the syntax. So what I will do, I will upload this revised file by deleting the previous file. Okay. So now if I simply let me change the window pane here, I will take my pane to the right hand side so that I have a big canvas to explain things. Yes. Okay. Now friends, all of you just pay attention. So here is my to the left of your screen, you have the script window, and to the right, you have your console window, which is a calculator. Yes. Now, now whenever you open your RStudio for the first time, please load the package. And for loading the package, the command is library. Now you need not install your package again and again because it is already there. Now, if you simply type seminar and put two dots, you'll get all the functions and all the data which is there. Yes, so now here there is one corporate reputation data. If you remember this, last time we used this corporate reputation data, which was shared with you. So now we are going to see one more data, which is known as influencer data. Yes, so seminar, double inverted columns and influencer data. So if I press enter, so this data. Now please note, whomsoever is developing a package, he has to provide data. Otherwise, CRAN is not going to include his or her package into its environment. By the way, CRAN is a source where you find all the packages and all the vignettes and all the PDFs. Yes, okay. So now, so yes, so for my understanding, I have written line number, syntax number, line number 5, SIC is a formatively measured construct. We did see in the model and we did see the items. It is a formatively measured construct. So let's load the influencer data. So now if you simply type influencer underscore data, this is how the data is stored. So simply run line number 9, you'll find that the data is here. So now whenever you import the file, or let's say whenever you load the data, you should also attach the file. Attach. Now this is a command, line number 10. When you use attach, in that case, you can extract a particular column. So let me run line number 10. So when you attach, yes. If you want to view this file, you can simply type view and just type influencer data. You can view it. See, you can view it in the script window itself. Yes, okay. So here you can see that SIC, SIC1, SIC2, SIC3, 4, 5, 6, and 7. So there are 7 items and there is one global item, SIC global. Please bear this in mind that whenever you are measuring a formatively measured construct, you should have one item which essentially captures the meaning of all the 7 items, which essentially captures the meaning of all the 7 items, because convergent validity in a formatively measured construct, its estimation is slightly different than the reflective measured construct. So we'll come to it. We'll come to it. Okay. So we'll definitely read the write-up and how the convergent validity in a formatively measured construct is established. We'll definitely look into it. Yes. Okay. Now again, there are 5 steps. Specify the model. Yes. Then create measurement model, create structural model, then estimate the model, summarize the model, bootstrap the model. So there are 5 recommended steps. Yes, we did see in the last time. You can go and see the previous video which is uploaded for you, and definitely you'll get idea. It's a 5-step process. Whenever you are using seminar package, it is a 5-step process. So I'm running line number 14, which is specifying the measurement model. So line number, if I just run this, select and run this. Okay, data is loaded. Now you can plot the measurement model. So let me plot the measurement model. Yes, and let me zoom this. Okay. So the moment I plot the measurement model, friends, here itself you can make sense. Okay, can anybody in this workshop tell me that out of the four constructs measured, which is a formatively measured construct? Yes, go ahead.
Sir, SIC.
SIC.
SIC. And you see the arrow is from the indicator to the construct, and PI, PQ, PL, they are measured as a reflective measured construct. Now bear this in mind. So there is one construct which is formatively measured. Okay, so now let me remove this. So you can plot it. So my measurement model is okay. Let me minimize this. Now let's second step is specify the structural model. It's mechanical one by one. It's very mechanical. So line number 24, I will simply select it and run it. Yes, now it's loaded. So the moment you get greater than symbol, it means everything is fine, everything is hunky-dory. Now run line number 28. So if I run line number 28, see. So this is the structural model. Now compare this model with the model which is given in your textbook. So see, so there is one arrow which goes from SIC to PL, SIC to PQ, and SIC to PI. So there is three arrow which is going from SIC to PI and two arrows going from PL to PQ. So now come here. So there are three arrows. See, SIC to PL, SIC to PI, SIC to PQ. Now here you see again PL and PQ, they are slightly they are opposite to each other. So it's a case of a parallel mediation. See, now you will see that diagrammatically or visually these two diagrams are different. The diagram that is there in the reference material and the diagram that is there, or the diagram that is generated by the R Studio, visually they are different. But if you see the path, it is same. There is no difference as far as path is concerned. There is no difference between the diagram that is generated by the R Studio and the diagram which is there in the reference material. So it's one and the same. Doesn't it's okay, it's fine. So now what I will do is that okay. So third step is
Sir,
estimate the model.
may I ask one thing, sir?
Yes, go ahead, Lovji. Yes. Go
Sir,
ahead.
on what basis we judge that we have to go for this mediation effect checking?
We have to go for
How we check that initially in this we have under our study we have to go for mediation effect? How, on what
no.
basis हम judge कैसे करते हैं?
Yeah, it is based on theory. It is based on theory. So let's say first of all, it's a very very interesting question that how do you decide that this particular construct is a mediation? So Loveji, go back to my notoriety success model. So somebody came out with a theory that notoriety leads to success. किसी ने चैलेंज किया नहीं नहीं ठीक है नोटोरिटी सक्सेस लीड करता है लेकिन कुछ मिसिंग है उसके अंदर तो किसी ने बोला क्रिएटिविटी शायद चेक करो एक जस्ट मेजर क्रिएटिविटी from those people who are notorious and who are successful. So you'll find that notoriety leads to creativity and then leads to success. Simply notoriety will not lead to success. By the way, there are lot many notorious people who are behind bars or who are in prison. So creativity is something which is very important for notorious people. If their energy is channelized, or rather, if they are if their pursuits are into some wonderful endeavors, then they bound to be more creative. Somebody will go and conceptualize. See, it is the researcher's call or the researcher's review of literature which will make him understand that yes, there exists a gap in the existing model. So you see, nobody can force a construct on you, or nobody can say take this construct and test the mediation. It is you who has to take a call. Okay, I find that the existing model, or for that matter, existing reality is missing on some very important phenomena. So you bring that phenomena by way of a construct. You do all the content validity, face validity, and then you operationalize that particular construct and you check the mediation of that particular construct, Loveji. So it is your call, your review of literature. Yes, okay.
So it means amongst the whatever the constructs we have selected from the previous study, because we are not going to scale up the new things, we have to find out the construct on the basis of the previous study. We have to find out the gap, and amongst those construct what we have selected, we have to find out whether there is a mediation effect or not. It's our
Yeah,
call only.
yeah. You're 100% correct. 100% correct. Let me switch off my board. My computer is overcharging. Now, Lovji, please pay attention. Go back to my first session. I said conceptualizing a model is an art. Now, I'll tell you what mistake I did normally. I am just a budding researcher. Yes, I don't claim that I know everything under the sky as far as quantitative research is concerned. But when I was conceptualizing a model, and this will be a nice example, I used to take any three construct and check the mediation. This is wrong. This is not. In fact, few of my papers are published by taking any three construct and trying to find a mediation. No, it's not like this. Again, I'm saying when you conceptualize a model, conceptualizing a model is an art. You require a lot of literature review, you require a lot of experts opinion. Yes. And you really have to do some sort of 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 pilot testing, and do lot of your own intuition and logic should come into devising a model. Simply don't go and say that okay, I want to test mediation because I know SEM and I can test mediation very easily. That is not the logic. By the way, if you try to bring any construct, statistically something or the other will become significant. So that is not important. That's why many papers, mediation papers, get rejected. The reviewers give the comment that there is no strong argument that you have given when you have proposed a mediation model. I remember when I wrote one of my paper and I wanted to send it to ABDC, I sent it to review. I sent it for review to one of the experts, and he said, please write a strong reason or argument as to why you feel that this particular construct is a mediation. Yes, mediation is, see again, any construct which you bring into the model, it should not be based on just bringing a construct for the namesake and testing the mediation. See, it is the normally what is happening that people are allowing statistics to develop theory. People are using statistics to develop theory. No, it's other way around. Conceptualize a theory and then test it by statistics. If stats says that okay, there is a mediation, in reality there might not be a mediation also. So that's why whenever you conceptualize a model, please understand that which particular sample you have chosen, how they behave, how they relate. It's very important that you go and talk to people. Again, let me be very critical of my own PhD thesis. So in my PhD thesis, again, there is OCB is a dependent construct. But if I go and show my model to people who are in pharmacovigilance, or people who are working in MNC companies like Cognizant, or for that matter TCS, or all those great companies, people will say your model will not appeal to us. That's why whenever I advise researchers, there are a lot many research scholars who are working under me. I advise them that please ask a question: why is your research important? What problem is it addressing? Or what new phenomena it is explaining? So you should always ask a question. Now, this is what my professors have taught me, and I'm passing on this message to you, that why is this study important, or why is this model important? So you should always ask a question: why? Whenever you conceptualize a model. Model is simply not pitting any three construct against each other and testing a mediation. By the way, there is something called a statistical folly. When I say statistical folly, it means statistics will somehow, some or the other, it will make certain things significant or insignificant. So you should not be too much governed by statistics. So what goes before statistics, that is more important. Hope Dr. Loveji, I answered your query.
Okay, okay, sir. It means previous study is most important, and
Yes.
if there is a significant, like results are showing something very significant, and your findings are justifying taking the previous study, and you are able to justify the things that there is a mediation effect. That is just because of this values you have checked it and you found the mediation effect. Then it
Hmm.
is indeed very true.
Yeah, yeah. Okay. By the way, tell me how many people are there in this class, Loveji? How many people are there? I can't see.
Sir, 13, sir.
13 are there. So maybe we're leaving 12 people are there. 12 people are very serious. Okay. So now we plotted the model. Now let's estimate the model. Third step is estimate the model. Yes. Okay. So the model is estimated. When you get this, all 220 observations are valid, it means everything is fine. Okay. Let's summarize the model. So this is a vector, and I'm simply summarizing the model. Okay. So the model is summarized, and let's estimate it. Okay. Now here you can see, if I can simply, when I summarize the model and just type the vector, here you see the path coefficients. Again, this is, let's try to interpret, but there is no p value or t value, but still try to interpret. So what is the r square? So the r square from pi SIC to pi. You remember pi is our main endogenous construct, the main dependent variable. So it is, so all the three means SIC, PL and PQ. So let me come here. So SIC, PL and PQ. Let me have this model before you so that that you are able to understand. So PI is your main dependent variable. So SIC, PL and PQ together, they are explaining 59%, close to 60%, decent. Yes. And PL, SIC to PL, it is just 22%. Means SIC is explaining 22% in PL. And if you take PQ, means SIC is explaining 16%, close to 17% in PQ, close to 17% in PQ. But let's say if you want to understand how much is SI contributing to PI only, how much is SI contributing to PI? I'm not talking. See, this is the total effect. This is the total R square. So if you simply, let's say you minus this, let's say 0.592 minus bracket start, and let's say if you minus 0.224 plus 0.167. So here SIC is explaining 20% in purchase intention. By the way, you will never find a direct effect. This is the total effect. Means all the three constructs together, they are explaining 60%. SIC on PL 0.224, SIC on PQ 1.67. And this is the adjusted R square. Adjusted R square normally will be lesser than the main R square. Yes. And here you see this is your beta value. Means SIC to PI, the beta is this. SIC to PL, the beta is this, and beta is this. By the way, when you see beta estimates, you always require p value in order to interpret whether this particular construct is significant or not significant. From simply looking at beta estimates, you can't make sense. By the way, these two beta values, 0.473 and 0.408, will be significant. This is what my intuition says, because it's a very decent beta. Any beta above, let's say 1.20, it almost goes significant. But this doesn't appear to be significant. So the direct path from SIC to PI doesn't appear to be significant. It means that it's a case of a full mediation. So by simply looking at the beta estimates, you can make a lot of sense. Okay. And then this is PL to PI. So PL to PI, this is the beta. So very strong relationship, very strong beta. And PQ to PI. So this is PQ to PI. So by looking at the beta itself, you can make sense. Okay. Now here you focus on the reliability. Reliability. Now, see, first of all, SIC is your formatively measured construct. So for formatively measured construct, there is no concept called convergent validity or discriminant validity. Particularly, there is no alpha for formatively measured construct. We don't see alpha for formatively measured construct. Yes, okay. So, but focus on this. See, by the way, if you see all the reliability indicators, they are greater than 0.70. It means your constructs are reliable. Yes, and this is your composite reliability. Again, it is greater than 0.70. It's reliable. And see your AVE, you should not see for AVE, that is average variance extracted. It is for reflective measured construct. It is not for formatively measured construct. But you focus on PL, PQ, and PI. All the reliabilities are greater than 0.50. Oh, sorry, AVE are greater than 0.50. So looking at these three values, here you see uh, the convergent validity condition in the measurement model is adequately satisfied. Means my reliability is greater than 0.7 and my AVE is greater than 0.50. So I will say convergent validity is established. Yes. Now you can go and test for the validity, that is for discriminant validity, for the reflective measured construct. Again, SIC, I am not seeing reliability, I am not seeing AVE. Now to establish convergent validity in a formative measured construct, things are slightly different. So now let's check the validity. So simply check validity, put again dollar, and here you see first Forner-Lerker criteria. So if you see Forner-Lerker criteria for the reflective measured construct, so this is greater than, so all the diagonal values are diagonal values are your square root of AVE. So your square root of AVE should be greater than on and off diagonal values. It means 0.907 should be greater than this, and 0.907 should be greater than values below it. Similarly for this one and this one. So Forner and Lerker criteria says that my constructs are discriminate. My constructs are unique. Here you can see FL criteria table reports square root of AV. So you can see square root of AV on the diagonal and construct correlations on the lower triangle. So now simply press the upper arrow key. Just remove this FL criteria, put dollars and check for HTMT. Yes. And again, you see HTMT, none of the constructs ratio of correlation values are above 0.85. So none of the values are above 0.85. It means my constructs are discriminant. So now you can go and report all these things. Yes. Okay. You can go and report all these things. Okay. So now, as far as reflective measured constructs are concerned, their convergent validity and discriminant validity is established. No problem with that. Now let's do one thing. Let's bootstrap the model. Let's bootstrap the model. By the way, now let me skip line number 47 to 60 and let me come later on because reflective. Yes, Felix ji go ahead. Yes, Felix ji go ahead. Yes.
Sir, good evening, sir. Sir, in the HTMT validity, we uh, uh, the diagonal value 0.625, which is less than 0.815.
No. Here we don't compare the on and off diagonal values. Felix ji, that on and off diagonal values is for FL criteria. It is for FL criteria. For HTMT, we don't compare that this should be greater than this. No. HTMT, we only see that none of the values should be greater than 0.85. That's it.
Okay, sir.
Okay. For FL criteria, we'll see the diagonal value should be greater than on and off diagonal values, which you call as AVE should be greater than MSV, and MSV should be greater than ASV. All these things are there. But for HTMT criteria, Felix G, we don't see on and off diagonal values. We simply see that the ratio of correlations between two constructs should not be greater than 0.85. That's it. So interpretation is slightly different. So if you read any standard paper, or for that matter, if you read Felix G, that paper, when to use and how to report. By the way, let me show you this paper, Felix G. If you this paper has been shared with you, Felix G. Just read this paper. Just read this paper. Here, let me go through it. Let me answer Felix G. So here, if you see assessing reflective measurement models. So here you see Felix G, there is a line. Okay, let me read it for Felix G. Uh, as a replacement, Hensler et al. Proposed the HTMT ratio of correlations. The HTMT is defined as the mean value of all the item correlation across construct. This is the formula actually. This is how you need to calculate. See, there are people who calculate HTMT manually also. You can write the formula and calculate using Excel and all, but I'm not going into all those things because we want to publish paper and we want to come to the logic and all. So Hensler et al. Propose a threshold value of 0.90 for structural models with constructs that are conceptually very similar. So when constructs are very similar, then in that case, HTMT should not go above 0.90. But if constructs are distinct, then HTMT should not go above 0.85. Yes, here you can see. In addition to these guidelines, bootstrapping can be applied, all those things, or a lower threshold value of 0.85 or 0.90. Felix. So for HTMT, we don't see on and off diagonal values. Hope it is clear.
Thank you, sir. Thank you, sir.
Okay, just lower your hand. Okay. Now, friends, as far as convergent validity, as far as establishing convergent validity of reflective indicators, PL, PQ, and PI, all starting with P, are reflective indicators, and their convergent and discriminant validity is established. But now, SIC, we have to establish the convergent validity of the formatively measured construct. Now, please remember, SIC is measured formatively. So for formatively measured construct, we don't see reliability, we don't see AVE. Now, for formatively measured construct, the convergent validity is established through a technique which is known as redundancy analysis. Redundancy analysis. So if your construct is measured in a formative way, the technique to establish convergent validity, it is known as redundancy analysis. So let me write, it's a technique technique for establishing convergent validity in formative constructs. Yes, okay. So so now SIC, how to establish the redundancy analysis. See, again, for formatively measured construct, there is no term called discriminant validity. Discriminant validity is not applicable to formatively measured construct. For formatively measured construct, there is only one term which is known as redundancy analysis, and this is nothing but establishing the convergent validity of the formatively measured construct. Okay. So now if you focus, see, now I'm skipping line number 47 to 60. This is why, because these are the estimates. We'll get beta value and all those things. But before proceeding for structural model, we need to uh, fix the issue with the measurement model. So reflective construct, we are done with it, but still first measurement model has to be satisfied, then go with the structural model. The rule is this: first measurement model, then structural model. So measurement model for reflective is over. Now measurement model for formative is still not over. That's why I'm skipping line number 47 to 60. So what I'll do, I'll simply do one thing. I will just take this line. I'll simply copy this and I will simply put it up. I'll just control X, and here I will simply, let's say, where should I put it? So summarize the model over. No, so here I will put this. So what I've done, I've simply copied and pasted it. Yes, and here what I can do, I can simply write estimating the structural model. Or let's say estimating the structural model. Estimating the for my ease I'm writing it, estimating the structural model. Okay. Yes. Okay. Now oh, let me put a line here. Just a second. See, suddenly this, when this come, see, when this arrow come, no, I'm not able to get rid of this dash bar. Now it will ask, okay, let me come here. Now see, this is getting a, just a second. Here I can get it. But here, okay, see, I'm getting this. So I normally don't get rid of it. So here in this case, what I'll do, I'll simply, what I'm doing, I close the R Studio. Sometimes it happens, and I will open the DRS file and load the syntax too. It happens sometimes. When you force R Studio, sometimes it gets annoyed and you don't know how to get rid of it, then you should close it and rewrite it once again. So what I did, I simply copied this particular part. No, bootstrap the model. Yes, I was here. See, now you can see. So here you can simply put a dash. And simply put a dash so that you understand later on what has happened with your data. So now what I'm going to do, I'm going to do the redundancy analysis. Now, before I proceed for redundancy analysis, let me take you to some of the write-ups. Let me take you to the, now all of you, again, this is the same paper, when to report and how to report the results of PLS SEM, published in A-Star Journal, European Business Review by Professor Hare et al. So here you focus assessing formative measurement models. So PLS SEM is the preferred approach. I'm reading this. All of you just pay attention. PLS SEM is the preferred approach when formative constructs are included in the structural model. Formative measurement models are evaluated based on following: convergent validity. Now how to evaluate formatively measured model? Yes, let me mark it. So you see the convergent validity, indicator collinearity, statistical significance, and relevance of the indicator weights. So we will focus on these four things. Yes. So whenever you are evaluating formatively measured model, you need to focus on convergent validity. Now, convergent validity in a formatively measured model is known as redundancy analysis. And then indicator collinearity. When I say indicator collinearity, we see VI values, variance inflation factor, and this value should not be greater than 3, or ideally should not be greater than 5. Then we see the statistical significance, p value, t value, all those things. And then we see the relevance of the indicator weights, whether the items that we have used to measure the formative construct, they are relevant or not relevant. So here again, you see, for formatively measured construct, convergent validity assessed by the correlation of the construct with an alternative measure of the same construct. Now, friends, please pay attention. Now see, now take example of our model. In our model, yes, if I can plot this model, just a second, if I can plot this model, okay. So this model, you all know that SIC is formatively measured. Yes. So now whenever you are working with formatively measured model, in the questionnaire stage itself, you need to include one item in your questionnaire which should capture the essence of the formatively measured construct, which is known as global item. That is known as global item. So here, if I can show you this particular data, my friends, but by the way, again, I need to library, have to invoke it, otherwise it will not function. Let me clean the screen because I have rerun the R Studio. Now, friends, all of you pay attention. See what I'm doing. If I simply type view and influencer data, yes, all of you, friends, all of you just pay attention. Hope the screen is visible. Hello? Hope the screen is visible. Hello?
Yes, sir.
Yes, okay. So now you see this SIC, it is measured using 7 items. So SIC 1, 2, 3, 4, 5, 6, 7. Now, apart from these 7 items, there is one more item which is known as SIC underscore global. So for formative measured construct, apart from measuring the construct using multi-items, there has to be one item which should be included in the survey, which should capture the essence of all the 7 items. Again, let me put it simply. Now, whether you are satisfied with this workshop, I will ask you 5-7 questions. The resource person was knowledgeable. The reading material was up to the mark. The resource person addressed the dynamics of the class nicely. The resource person, let's say, he was able to stimulate discussion in the class. So let's say if you want to measure how good the resource person was in the workshop, you can ask 5-7 items. Yes. And apart from this 5-7 item, you should ask one question which should essentially capture all the 7 items in one question. Yes. So let's say if I give you a scale, a question, and I say, will you recommend datamatics research workshops, future workshops to your friend or colleagues? Or let's say, will you forward the PDF file in your WhatsApp group? So if you say strongly agree, or let's say very likely, then it means, okay, you are satisfied, and this is going to be reflected in your action. So what I mean to say, now let's say, now I remember one person posted a doubt couple of months back, that I forgot to include SIC global, or one item capturing the essence of all the 7 items into my questionnaire, and I collected the data. See, once you collected the data, then you can't have one item measured from the same set of respondents if you can't go back and collect it. So in the research design stage itself, or in the questionnaire design stage itself, you need to be very sure that apart from measuring the formative measured construct using multi-item, there has to be one item which essentially captures the meaning of all the 7 items in one item. That's it. If you forgot to do it, maybe you can't redo it. That's why you have to be very careful, include one formative one global item, so that you can go and check the redundancy analysis. By the way, you should also read this book. By the way, the primer, or again, a primer on partial least squares. This is a book, latest edition, 3rd edition I have shared with you. And here you can go and check the evaluation of the formative measured model. So here they have given all the criteria. Here you see Assessing results of the formative measure models. Many researchers incorrectly use reflective measurement model evaluation criteria to assess the quality of formatively measured in PLS SEM. It means you can't use the criteria which is given for reflective measured or RC for FC. Yes. So here it says assessing. Now I'm reading randomly here and there. Assessing convergent validity and discrete validity of formatively measured constructs using similar criteria to those associated with reflective measured models are not meaningful. Yes, and Chin has done an excellent job of giving us this redundancy analysis technique. So here, if you go, they are talking about assess convergent validity formative measurement models. First step, see the collinearity. Second step, relevance and significance of formative indicators. And then assess convergent validity. And convergent validity is known as redundancy analysis in formatively measured constructs. So Chin has given us this solution how to establish convergent validity of FC, formatively constructs. Now here you see, now all of you just pay attention. See how can you see this diagram before you, all of you? Just pay attention. So let's say Y1 is measured using multi-item X1, X2, X3, X4, and it is formatively measured. Yes. And there is one more item which is a global item, and that is a okay. So there is Y1 which is reflective, XY, XY, X6, X7. And here if you go down, they have talked about how to do item generation, how to select that one item. They have given all the rules and regulations. So you should read this paper. By the way, people who will be working with formatively measured construct, they should you read this paper by Chi et al. By the way, this book has a reference. You should see what is the name of that particular paper, download it and read that paper. That paper will contain statistical technique of establishing convergent validity for FC. Okay. So here you see they have written in detail as to how to establish convergent validity, and they have given the correlation metrics for VIF. Read this book. In fact, when I was reading this book, it was making me a lot of sense, and I really enjoyed reading this particular item. So you should go and read it. Again, here you see this is what formatively these two management competence, economic performance, they are formatively measured, and this is then you take all the 5 items and then you measured performance, which is a formative construct. Okay. Yes. Okay. So this is the way you need to do it. Now let me take you to my syntax. Let me take you to my syntax. Yes. Okay. So now friends, pay attention. See now again pay attention here. So again, what we will do, again, what I'm doing, I'm again creating the measurement model. Now here, if you focus on the syntax, I'm creating measurement model between SIC, the 7 item, and the one single item. See, how is convergent validity established for formatively construct? You simply try to find out that the 7 items correlation with the single item or the global item correlation should be greater than 0.7. If the correlation between multi-item formative construct is equal to or greater than 0.7 to the single global item, we say convergent validity in a formatively measured construct is established. So now if you focus on syntax number, line number 51 to 54, this is nothing but I'm going to establish the correlation between, or rather I'm going to calculate the beta value between SIC formative and SIC global. So I'm simply running line number 51 to 54. Yes, okay. And then I'm again creating the structural model. I'm simply keeping my cursor on line number 58. Need not select it. Even if you don't select it, it will run it. And then estimate the model. Keep your cursor line number 63, run it. All 22 observations are valid. And simply summarize the model. And just see this line number 73. So line number 73, when I ran line number 73, my friends, by the way, let me do Control S. Here you see on this value, the relationship between this value is nothing but beta value. So see, when you have only one independent variable in your regression, yes, the relation and the beta estimate will be the same. The regression and the beta estimate will be the same. So the relationship between SIC and SIC global is greater than 0.70. So when correlation between SIC global and SIC multi-item is greater than 0.70, we say convergent validity is established. As simple as this. Very simple. It's not a rocket science. We simply need to find the correlation between the multi-item and the single global item, and it should be greater than 0.70. When this happens, we say that convergent validity is established. Now, the idea of discount validity, it is not applicable to formative constructs. Please note this. Now, after this, what I'll do, I'll bootstrap the model. See, initially in my analysis, I first ran the bootstrap and then I was doing formative. No, that is a wrong technique. So I understood it, course corrected it. Now I'll go to line number 79 and I will simply bootstrap the model, all the model, which has both reflective and formative. So what let me do, let me run line number 79. Yes, okay. So this is bootstrap. Here you can see the red blip. So the model is running. So by the way, this bootstrap should always be, whenever you are doing TLS SEM, this bootstrap should be 10,000. Just remember this. But if I go for 10,000, it will take at least 15 to 20 minutes. So for ease, I've taken only 500. But when you are running your analysis, you should do it for 10,000, not lesser than that. Yes, okay. 5,000 will also do, but always go for higher. Now, now again,
So, sir,
yes,
sir,
yes.
sir, actually, there was some interruption in between. Sir, what did you say about SIC if the value is 0.717?
Then this shows that the correlation between SIC global and SIC is greater than 0.70. Then we say that convergent validity of formatively construct is established.
Okay.
Okay. Then I bootstrap the model, then summarize the bootstrap model. Yes. Okay. Okay. But now the question is, convergent validity is established. But I need to check all the loadings and weights, whether, see, for reflective constructs, if the loadings are lesser, we go and delete it. But again, I said deleting a item in a formative construct, it is not that easy. So now you need to check the weights. Just simply check the weight. So you see weight, focus on this particular thing. See, weights are checked only see, this is the estimate, or rather this is the weight. Here you see simply, or let's say if I can show you, simply see, I bootstrap the model and just summarize the model. Just Control C and copy here, Control C, V, and put dollar sign. The moment you put dollar sign, so whenever you're working with formative construct, you should check the weight. You should check the weight. Check the weight. See, this is the weight. And see, check the weight and check there whether they are 6. See, I'm checking only for 7. By the way, weight has to be checked only for formative, not for reflective. I'll check only for this. You see, SIC1, there is 0 comes between lower and upper confidence interval, means this is not significant. SIC2, see, except SIC2, my friends, except SIC2, all the confidence interval includes 0. So now first indication, people will say these items are not significant, so I should go and drop it. Now here the author says, no, stop. Don't drop simply by looking at the weight. If your weight is not significant, you should go and check the loadings. Now how to check the loading, my friends? Please press the upper arrow key, go back, put dollar and check for loadings. Check the loadings. Now this loading should be greater than 0.7, should be greater than 0.50. You see all the loading except SIC5, all the loadings from 1 to 7, SIC 1 to 7 are greater than 0.5. Now the question is, should I go and drop SIC5 looking at the loadings? Again, the answer is no. It's not that easy to drop items in a formative construct, because remember, the item in the formative constructs are slightly unique. So when you drop it, the uniqueness of that particular construct might be questioned, or the uniqueness of that, or if you delete a unique item, the construct validity might be questioned. So therefore, be very what you call as, be on your guard, or don't be so what you call as complacent in deleting one particular item in the formative. And again, if you see this particular confidence interval, there is no 0. I'm going to retain it. So I'm not going to drop any item in the formatively measured construct. Yes, okay. Now since you have bootstrapped the model and you have checked for the loadings and paths, now you can go and run line number 90, and you can see you can see the direct path. Now this is a direct path. Huh? By the way, this is the direct path. So SIC to now let me do one thing. Let me slightly zoom this. Or yes. Now SIC to PL, is it significant? Yes, it is significant. See the T value, T greater than 1.96, and no zero lies between lower and upper confidence level. Yes, okay. Now see for SIC and PQ again. So SIC PL significant, SIC PQ significant, but SIC PI, remember it is not significant. See, when I saw the beta value of SIC PI, even without seeing the T value in confidence interval, I said this might not be significant. Looking at the beta value. Yes, and see, this is the beta, and this beta was similar. This beta was similar to what you got in this model. See, yes, okay. So let me rerun it. Upper arrow key. This is path. This is a dollar, and here I will simply take path. So you can compare the path. You can compare the path. And I said this SIC and PI will not be significant. And here, see, this is not significant because 0, minus, and plus comes, and 0 lies between here. And again, this PL, PI is significant, and PQ, PI is significant. Okay. Now, these are the results of direct effects. These are direct effect results. Now, the question is, there are two mediation. So one path goes from PL to PI, and the other path goes from PQ to PI. Mediation, I haven't assessed it. Now, how to check for mediation? And at the outset, we discussed that this is a model where it's a case of a parallel mediation. So now we need to go and check the parallel mediation. Yes, okay. So now this is done. Okay. So okay. So now what I'll do, I'm skipping all this line, and straight away I'm checking for uh indirect effect. Well, let me do one thing. Let me copy this line and keep it up. But I'll do it on my own, and later I'll send you the file. So let us assess indirect effect, my friends. I'll tell you one interesting fact. All of you just pay attention. Now, there is one package called PLSPM, and there is one package called SEM. I haven't touched this package. Might be on the last day, I will be touching this package for all of you. Now, the beauty of seminar package, which came just 2-3 years back, the beauty of seminar package is that it allows you to estimate indirect effects which are nested in the overall model. So let's say there might be 2 mediation, 3 mediation, 4 mediation, and number of mediation. Let's say the model is complex. Seminar, it will allow you to estimate specific indirect effect. And this specific indirect effect was the feature of Smart PLS software, or VAR PLS, or Edenco. So there are software Smart PLS, VAR PLS, Edenco. So if you're working in that, there you were able to assess the specific indirect effect. Now I can tell you this from my experience that when I started coding for my PhD thesis, I relied heavily on PLSPM. Then I realized that PLSPM is not giving me the indirect effect which is there in the model. Then I went for CSEM. CSEM is very complicated. Again, I was not getting the indirect effect. So then I said, okay, what to do? Then lastly, I said, I'm not able to get the indirect effect. So at the fag end of my PhD thesis, I bought Smart PLS4. At that time, Smart PLS4 came. I bought it for 1 month, paid 2,000 rupees, and reran the same model, whatever I was doing for, let's say, 2 years. And then I got the indirect effect from Smart PLS4 software. Or somebody will go and question you, why have you wasted your 2 years coding in our studio when you could have simply spent 2,000 rupees? And it's a valid question. But by the way, when I bought Smart PLS4, at that time seminar package had come, but I had no motivation left to run the analysis third using the seminar package. And I thought, okay, now I'm end of my tether, and I should rely on some proprietary software. So this is my story. And I was very honest in reporting also. So when I wrote the statistical analysis part of my PhD thesis, I reported there. Okay, so direct effect were estimated using PLSS, PLS, PM, CSEM, and indirect effect was estimated using Smart PLS4 software. And by the way, 2 years back, I was working on a project called Validity. Validity is a Smart PLS4 software. the diagram that you see in my PhD thesis that I showed you, yes, the diagram was, I have plotted the diagram using seminar because plotting was easy. Plotting was easy, simply plot and plot the structural model, you'll get it. So plotting in my PhD thesis is based on seminar package. But I had no motivation left to go. And at that time, I had not explored seminar package in detail. It just came recently, and there were not many people who were talking about it. But I didn't go and explain how to calculate specific indirect effect. But yes, I found the model presentation or the pictorial presentation of model in seminar package to be quite decent. So I like that. So I use seminar package to give the diagram in my PhD thesis. Now, I think my friend Kiran and couple of others want to write their PhD thesis. It's perfectly fine to use seminar package and do all the analysis. By the way, uh, I've been conducting this workshop. I don't know. I think this is the fourth time that I'm teaching PLSSEM to research scholars and faculty members. And I'm very sure, and this belief is I strongly believe this, that seminar package itself, it's foolproof. Foolproof means whatever analysis you want, you can do it simply by click of a button, and you can reproduce in your manuscript, and you can publish your paper. No harm with it, and it's perfectly fine to do it. Yes, okay. Now friends, focus on line number 120. Yes, focus on line number 120. Let me remove this AZ. I was practicing something because I wanted specific things from that. Yes, okay. See, working with R is all about trial and error, my friends. You'll do a number of mistakes. I think Professor Love was trying, and he had a lot of difficulties in using particularly importing a file and all. I had similar issues when I was working with PLS, SEM, and CSM package. So for a couple of days, I used to sit for 3 hours, 4 hours, and I never used to get a complete solution. So I used to switch off my laptop and do whatever I want. Second day, third day, I used to open up fresh and Google here and there, and see some YouTube videos here and there. Maybe I could get some solutions. So again, it's all about trial and error. And today I have achieved that stage. For that matter, I'm at that state that I have no fear for R. And you take me to any place or any seasoned place, I will be happily be able to teach any people how to use R. By the way, this workshop I have not taught you R, but I've been to many places in India where I simply go and teach people how to use R. Okay, so yes. So let's see specific indirect effect. By the way, can you see this command now? Now, if you can see this specific underscore effect underscore significance, this is a function. This is a function. So let's say if I type seminar and let me put two dots. So here, if I go down, see, by the way, every function here, if you see, this is a function. PQRS. Wait, I'll show you this. Um, can you see this? This is a function. This is a function. And if you want to know how to write the syntax of this function, simply put a question mark at the beginning and see. This is how you will use it. So this is the seminar package provides a natural syntax for researchers to describe PLS structural models. Specific underscore effect underscore significance provides the verb for calculating the bootstrap mean, standard deviation, p-value. Yes. So it will see specific indirect effect you can do manually also. But p-value, t-value, confidence interval you can't calculate manually because that is based on bootstrap procedures. So let's say you gave a bootstrap of 10,000. So let's say if you're writing 10,000 bootstrap subsamples. So the software is going to generate 10,000 results. It will test the result 10,000 times. And if many times it is significant, then it will give you a significant results. So this is a function, my friends. I have not created this command and syntax. The developer have created it. And the command is written here, how to use this specific effect. Can you see this here? Yes. Okay. So here it is there. Specific effect significance. Now here I want to check. Now, friends, please pay attention. Please pay attention. Let me use that plot function. Where is that plot function? Just a second. Just a second. Uh, Now, friends, I want to check whether PL mediates the relationship of SIC and PI, or PQ mediates the relationship of SIC and I want to check two mediation. Now, let me put it here. So one mediation is SIC, SIC PL, or let's say PQ. Let me take PQ first. Uh, uh, PQ and PI, and second mediation, let me press the upper arrow key. I want to check for PL. So these two mediation I want to check. Hope it is clear. So first mediation, let me check whether PQ mediates the relationship of SIC and PI, or whether PL mediates the relationship of SIC and PI. So let me do first, I think the syntax is for PL. So let me check it for PL, and let me minimize this and let me run this. Let me slightly make this one. Line number 120, I'm running it. All of you pay attention. Now, can anybody tell me, does PL mediate the relationship of SIC and PI? Can anybody tell me? Felix, you go ahead. Unmute and tell.
Sir, significant, sir, since there is no zero in it.
Yeah. And you see, this is the beta. This is the beta. This is bootstrap mean. This is bootstrap standard deviation. This is T greater than 1.96, and no zero lies between. No zero lies between this and this. See, sometimes your p value is significant, but your bootstrap result in the lower and upper confidence is not significant. Then when there is a dichotomy or when there is a dilemma, you should always go for this result. This is more robust result. Bootstrap confidence interval is a more robust result. Please note this. If there is a dilemma between p value and bootstrap result, you should always settle for bootstrap result. Yes, okay. Now similarly check for line number 126. That is SIC PQ PL. I want to check for this, and this is the syntax. So let me run it. Yes. Is it significant? Okay. Afrin is there? No, Afrin is not there today. Sonam is there? Sonam? Sonam?
Yes, sir, I'm here.
Is it significant?
No, sir, because there is the confidence interval does not, it contains a zero in between it. And the T statistics also is lower than 1.9 for the value.
Yes. Okay. So there is only one mediation. There is only one mediation. Okay. Now, if you want, you can simply plot this. You can simply plot this. Let me plot this. Let me plot this entire diagram. Now, I want all of you to pay attention. See, syntax is there. Please go and practice. Okay. So let me, okay. Let me hide the annotation because I can see alteration 14. Okay. Now, friends, all of you pay attention. Kiran is there. Kiran. I'm forgetting the name of my friend who's from Kolhapur. I'm forgetting. Sorry, Abhishek. Who's my friend from Kolhapur? Who is that friend? My friend.
Sir, I am Gandhali.
Gandhali. Now, Gandhali, can you
Yes,
see the
sir.
diagram before you?
Yes, sir.
Yeah. Okay. So what do you find? So which relation? See. Now see, wherever you see dark lines, my friends, wherever you see dark line, those relationship are significant. So SIC to PL, this is the beta. Beta is 0.473, and there are three stars. It is significant, and 95% confidence interval is given. PL to PQ, again, this is the beta, significant, and confidence interval. SIC to PQ, again, this is the beta. This is significant. See, the path from SIC to PI, this is not significant. See, the path from SIC to PI. So it means there is no direct effect. So there is only one indirect effect from SIC to PL to PI. SIC to PL to PI. So I can say perceived liking mediates the relationship of SIC and PI. But I can't say for PQ. Perceived quality does not mediate the relationship of SIC and PI. By the way, if PQ and PI is not significant, how can there be a mediation? Yes. A should be significant and even B should be significant. Remember that C dash plus A and B. If A is significant, B also should be significant. Then only there could be a mediation. Otherwise, there could be no mediation. So this is the visual representation of the what you call as parallel mediation model. Hope so far all your doubts and queries related to mediation it is over. So this is a detailed model that we have seen in the class, and this is an example of a marketing. I have been always criticized by a lot many people, sir. You are from OB and you give only OB examples. So in every workshop, wherever I conduct workshop, I always see to it that I change my syntax. I always use new syntax, new file. And by the way, it's very hectic for me that before the workshop, I have to first sit and code it, and then I need to send it so that we all are on the same page. And by the way, this particular diagram also gives you a lot of information about loading. You see SIC, SIC. You see SIC, this is weight. You see everywhere you can see lambda, lambda, lambda. This is a lambda symbol. It's a Greek symbol. But as far as SIC is concerned, and if you see the relationship of SIC with its indicators, yes, here you see that W is written. It means it's a formative construct, and here we assess the weights. And all it's perfectly fine to take all the weights. But in your paper, you should write an argument about your SIC construct. You should report their weights separately and give all the arguments stating that yes, my SIC is fulfilling the convergent validity requirement and it passes the test of redundancy analysis. This argument you need to give in your paper. Hope this makes a lot of sense. Okay. Hope this makes a lot of sense. Any query, any doubt? By the way, let me do one thing. Felix ji, you can go ahead and let me stop sharing and talk to you.
Sir,
Yes, Felix ji, go
Sir,
ahead. Yes.
sir. Sir, at that screen, sir.
Pardon, pardon.
Can you share that plot graph, sir, of
Okay, I'll share it. I'll share it. Felix ji, tell me. Yes.
here the weights for formative construct SIC. We first check whether the weight for each measure, whether the weight is
Significant or
and here only one thick line and 3-star highly significant.
but again I said no, it's not that easy to drop items from a formatively measured construct. By the way, it's a very good question that you have asked, and let me take you to this paper, Felix ji. It will address all your concerns. Or just a second. No, not this paper. A primer mein hai. Just a second. If I go here and formatively measured. So Felix ji, this is we need to follow. In fact, I followed this first. Indicator weight significance testing. Indicator weight is significant. Continue. Don't check any other thing. Felix ji, if your indicator weight is significant, don't do anything. Just retain it. But in our case, indicator weight was not significant, so we had to follow all the steps till up to down. Yes, Felix ji. Hello.
Yes, sir. Yes, sir.
So our weight was not significant. You see, only one item was significant, rest were not significant. Then if your weight is significant, fine, don't go, leave it, redundancy ho gaya. Matlab, at least uska issue nahi hai. But if your indicator weight is not significant, as in our case, then analyze the formative indicator loading. And if you're seeing the loading, if the indicator loading is less than 0.5, then test the significance of the loading. The indicator loading is less than 5, not significant. So we'll see the loading after weight. We'll see the loading. And if the loading is less than 0.5 and not significant, we will delete it. But if the loading is 0.5 or less than 0.5 but significant, I'm going to retain it. So this one paper or one diagram, actually I implemented in evaluating the weights of the formative construct, Felix J. Now you can ask doubt.
Sir, in the that is in our suppose the weight is not significant, we are checking for loading, and if the loading is less than or greater than 0.5, we say that we keep the
we keep it. And let's say if it is less than 0.5, then we check the confidence interval. Okay, we check the confidence interval. So let's say if it is less than 0.5, but if we check the confidence interval, 0 is not there, again we are going to retain it even if it is less than 0.5. I mean to say you have to very choosy and very particular that you can't certainly delete an item from a formative construct, because ultimately the construct validity will be affected.
Sir, can you scroll little down, sir? Can you? So here, when it is significant, when the loading is less than 0.5, we check the significance, and if it is there, then we don't remove, we retain it. But if the loading is less than 0.5 and it is not significant, then we delete it.
Yes, the indicator loading is less than 0.5, not if we delete. Okay. Here the loading indicator is less than 0.5 but significant. Consider removal of the. Again, here you can remove it. Okay. Again, you can remove it. But if you take our case, Felix G, so here if I can show you, and if I see all the weights were insignificant, so we see the loadings. So when I see the loadings, See, you focus on the loadings. All our loadings, focus on this original estimate. These are all greater than 0.5. This was less than 0.5, but still it is significant. Now somebody will say, okay, delete SIC 5. Delete SIC 5. Very good question. Huh? Very good question. I really appreciate. So now it is your call, Felix G. Now the indicator loading is less than 0.5. Okay, let me show you this. Actually, this is the case in our case. Now we are here, Felix G. We are here. The indicator loading is less than 0.5, but significant. Now still you can remove this item. Consider removing this item. But I'll not remove it because this is one item and it's not affecting too much.
Since I have 7 items, do I have the freedom to remove?
See, in this case, yes, you can definitely do it. You can definitely do it. Yes, in this case, you can definitely do it. No harm in doing it. By the way, if I can take you to this particular, read the items. No, read the items. Or let's say this is a seminar package, and just a second. This is yes. See the items. LXG, see the item, which is the 5th item. I think the influencer helps me become the type of person I want to be. Again, if you remove this, no harm. Rest of the constructs are actually measuring what you intend to measure. Still, you can go and remove it. You can go and remove it. But since loading is significant, I'll not remove it. And one item is anyway, it is not causing any big harm. But still, Felix, literature says you can go and remove it.
Okay, sir. Sir, for a formative construct, what is the safest number of indicators I can keep, sir?
Again, no, there is no threshold. It is up to you. See, again, how much indicators you keep. Normally, if you are using an established scale, then you don't have call. You have to accept whatever it is there. But if you are developing your own measure, then you have to take an expert interview. You have to give your, you have to establish the content validity and the face validity of the constructs. Again, in my understanding, 4, 5, 6 item is 4, 5, 6 item is sufficient. But try to have some good number of items which actually captures the essence of that particular construct. And but how many items to keep? Actually, that is what you call as a question which would fall in the arena of skill development. And normally, all the skill developers take at least 5, 6 or 7 items. They definitely keep it, anticipating that some of the items will not load it or some items will not give justice to it. So they keep 5, 6 items. No harm in keeping 5 or 6 items into the formative construct. Let's say if you are developing a construct, measures for the construct.
Sir, in my research, I have a second order construct, sir, and it is reflective only. But I have many first order constructs, and the questions are
okay. So definitely will not today. Tomorrow will definitely. In fact, I have a lot of syntax for second order construct. In fact, in my previous workshop, I didn't touch the models which are there in the data set or the models which are given in the seminar package. I give models based on my PhD thesis, and even my PhD thesis there is a second order construct. So for Felix G, I have the syntax I can teach you, but actually that is not today's plan. And tomorrow what we will do, we will take a higher order construct. Felix G, that will answer your answer. It's very simple. It's very simple step. You can do it. But using a second order construct and establishing the predictive validity of the model is slightly complicated because anyway, if you're running PLS SEM, people will ask you, okay, your structural model is fine, but is your model valid for future observations or does your model pass the test of predictive validity? So people will ask you that particular question. That's why you need to run the PLS predict procedures. So PLS predict procedures in a second order construct is slightly complicated. So tomorrow, definitely what we will do is that we will take a model where there is a construct which is a higher order construct. Yes, I have the syntax, but right now it's not planned, and let's not deviate from the main flow. But definitely, I'll definitely help you with that. Okay.
For PLS predict, it is coming under the model robustness, sir.
No. Model robustness is separate. PLS predict means you are establishing. See, now you have used the existing data, and you say my R square is decent and my structural paths are significant. What if a new data is collected and the same model is tested? Will this model be valid? Now, let's say when you tested this model, you got R square as 50%. Now, let's say Sonam went ahead and she tested the model, she got R square as 60%. So now different people are getting different explanatory powers of the model. So now you need to go and establish that, yes, for my sample, this model is correct. And in future, if this model is tested, again, it will be correct. So that is establishing the predictive validity of the model, and that is not part of model robustness checks. In model robustness checks, Felix ji, we focus on three things. We focus on linearity effects, we focus on endogeneity, and third, we focus on unobserved sources of heterogeneity in the data set. So there are three things which are part of model robustness checks, and the last day of the session is devoted for checking whether my model is robust or not. Yes, to answer you, predictive validity is not part of model robustness checks.
Okay. So in predictive validity, we need to have test data and validating and
So that definitely will see it. That definitely will see it. Okay. So let me talk to you first. Let me talk to you because in fact I think measurement model, structural model issues are sorted out. We'll take one higher order model maybe tomorrow, not today. I have the syntax. My own PhD thesis is based on higher order models because whenever we work in real life phenomena, we have a lot of higher order models. So definitely we'll take that. But by the way, any query anybody has, you can ask me. Yes. Kiran, go ahead. Yes. Kiran first, then Sonam
Yes.
second.
Sir, actually, if there is a scale where we are not looking for reducing any indicators or any dimension, in fact, we are trying to retain all the items. So it is such that the constructs are, I mean, each construct has only single item, which we
Yes.
are supposed to retain. So what are the different tests which we can use to prove the regressness of the method, and so that we can prove that the scale is
Okay.
valid?
So you mean to say if there are single item that you have adapted from a scale? Yes.
Sir, actually the item is created by us.
So see, as far as single item is concerned, Kiran, you can't check the reliability and validity, all those things. But if you read the book Primer on PLS SEM, there they talk about how to establish the content validity and the face validity and the statistical validity. I'm using a separate term of one item construct.
Okay.
Yes. Okay. So just read the formative part of the primer on PLS SEM. So there they have given steps. Let's say, Kiran, even if you create one item to measure a particular construct, again, there are stages of scale development that you need to follow. The first
Right.
step, you need to talk to experts. Yes. Then second step, again, there are certain reliability estimates for one item. Yes. So there are steps which are given in the book that you need to follow. Yes. So one item it's perfectly fine because in real life phenomena people don't have time to answer multi items, and it's always better to have a one item kind of a measures. It's perfectly fine, but again it has a process which needs to be followed. One another thing is that if let's say if you have not created it, but if somebody else has created it, that you can pass the buck of all the validity, particularly content phase, to that particular author. But since you are developing a one item to capture the essence of a construct, then you need to elaborate as to how you decided that yes, this is the item which is going to measure what I'm intending to measure. But by the way, I still insist you go and check the literature. There might have been people who have used the similar item which you are using, and they would have measured that particular construct. Then in that case, no harm in passing on the buck to that particular author and citing that author in your literature.
Okay, sir. Thank you, sir.
Okay. Any other Sonam, you raise your hand. Come on, Sonam. Sorry, I did not see first.
Sir, it's okay. Sir, I just wanted to know कि अभी आप जो बात कर रहे थे कि PLS predictive जो भी था, तो ये चीज हमें तब करनी है ना when we are using PLS SEM. When we are
Yes.
using AMOS, we are not supposed to do this thing, na?
See, in AMOS, there is no concept of predictive validity of the model. But in PLS SEM, you read every literature in good quality journals, Sonam. People talk about predictive relevance of the model. So whenever you are running PLS SEM, you have to talk about whether your model is valid for future observation. You know why? Because PLS SEM is a non-parametric approach to structure equation modeling. The concept of bootstrapping, if you remember, is especially applicable to PLS SEM. I don't know much about Amos and all, whether you do bootstrapping or not. But in PLS-SEM, definitely we always bootstrapped our model. And why do we bootstrap? First is because it's a non-parametric method. So whenever you depend on non-parametric method, it is always advisable, and rather it is must, that you should establish the predictive validity of the model.
So, sir, this can be done in seminar, no?
Of
जो
course, it can be
predictive
done.
है.
I'll show you. I'll show you. In fact, if I don't
Okay.
teach you predictive validity of the model, there is no point in teaching SEM. So definitely in the next session, we are going to talk about the predictive validity of the model and what are the statistics that we need to evaluate. And say, whenever you are using PLS SEM, Sonam, and all my participants, you have to mention about the model's predictive validity. It's mandatory. Please take it from me. Simply stopping at structural model will not suffice. So in PLS SEM, once you establish the relationship direct and indirect effect, then go and talk about the predictive validity of the model. That is must, that you need to talk about it.
Sir, is it same like when we use emos now? So bootstrapping is there, but that is used in case when we are using mediation.
When we
In
are
Jamsa
using,
simple
when we are using,
mediation and
okay,
all,
okay,
then
okay.
then we need to do the bootstrap. But is it like जो predictive की बात आप कर रहे PLS predictive, is it similar to when we are using MOS, we check some model fitness indicators like CFI, NFI, TLI. So that indicates the fitness of the model, data fitness to model. So when we are talking about PLS predictive, तो ये दोनों चीजें सेम है क्या? मतलब MOS
No,
में
no,
करते हैं तो
no,
हम वहाँ पर वो
no. In fact, see, the beauty of CBSEM is that you have lot of model fit indices. Yes, and that's why the concept of uh, predictive validity of the model is not applicable to CBSEM. Please note this. And predictive validity of the model issue is there only with PLS SEM, because model fit is not the characteristic of PLS SEM. PLS SEM will not talk about model fit indices. However, having said this, of late, Hansler and colleagues, they are talking about model fit indices in PLS SEM. But to answer you in specific terms, CBSEM, there is no predictive validity because there are model fit indices. I think you only gave the answer. And PLS SEM, there is PLS predict.
Okay, sir. Okay, thank you, sir.
Yeah, okay. Anybody else?
Yes, sir. One question, sir. For bootstrapping, generally in Stata, we give 5,000 for it goes to iteration of 5,000 or something they ask for. Sir, how much here we have to provide? Like
Okay, yeah. So
5,000 or 10,000?
see, again, if you read the primer on PLS SEM, it talks about 10,000. It talks about 10,000. Don't go about 10,000. 5,000 is also fine. But I would see when I run PLS SEM, I use 10,000. So standard is 10,000, sir.
Okay.
Loveji, one number, take 10,000 for PLS SEM.
Okay, sir.
Yes, okay. So it's now close to 7:45. So let's do one thing. Let's take a break and we'll back at 8 o'clock and we'll talk about certain advanced issues in PLS SEM. Okay. So stay connected. We'll back by 8 o'clock. Thank you. Okay. So I just saw the chat section. I think Kiran is experiencing certain errors while she is running the syntax. Kiran, is the issue resolved? Or?
Yes, it is resolved, sir.
Okay, great. So 1 minute to go, we'll start. I said no, on the fag end of the session, you'll find that only few people remain, even if they pay also. So on the last day, you'll see that 5 to 6 people will be there. Rest everybody will run away. Okay, so it's 8 and let's begin. Now we are 10. So 2 people are almost lost now. So let me share the screen and let me focus on certain important issues now. Yes, okay. So far we have uh, known how to uh, estimate the measurement model for reflective construct, for formative construct, structural model. Anyway, it is same for all the model. Yes, okay. And now post evaluation of measurement model and structural model. Now there are certain other issues which are very common to PLS SEM. I think Sonam asked us the very right question that predictive validity of the model, is it applicable to CB SEM or PLS? Is it applicable to both the methods of SEM? I said no. Establishing predictive validity of the model, it is applicable only to PLS SEM. And in CBSEM, there is model fit indices. So that's why their predictive validity of the model is not a concern. Yes, we'll hardly find that in CBSEM people talk about predictive validity of the model. But of course, in any PLS SEM paper, people will definitely talk about the predictive validity of the model. Okay. So now let me do one thing. Let me show you some of the papers where people have talked about predictive validity of the model. Yes. So let me. This is one of my favorite paper, A Star European Business Review, and again this is a paper which talks about the same model that we have tested psychological ownership in social media influencer marketing. In fact, the parallel mediation that we checked, SIC leads to PL, PQ, and then PI, is more or less resembling to this particular paper, but this paper is altogether tested a very different model. Yes, okay. And this paper is written by one person, okay, and is from Germany. So wonderful work this professor has done. And one of my, I'll just deflect from what I'm teaching now. One of my professors, he used to teach us that instead of writing 100 papers, write one paper which is equivalent to 100 paper. So, it's a very interesting thought that now you'll find that many of your colleagues, they have many papers, and okay, you write one paper which is equivalent to all of their papers put together. So do that work, let that master stroke come sooner or later, but let it come. Okay. So here, if I go down, see, this is the model that the professors have tested, and this is, they describe it as a hypothesized model. So here, if you see, they have one construct called influencer credibility, and it is a higher order construct. Felix, this is a higher order construct. We'll see it tomorrow. And you see, 1, 2, 3, 4, 5, 6. There are 6 constructs, and every relationship is a hypothetical relationship which they have gone and tested. And it's a wonderful research paper that you should read. It's been shared with you. And here, if you focus, so results. So they have spoken about measurement model evaluation. Yes, and they've used only HTMT ratio, and they have not spoken about Forner-Lercher criteria. Have they spoken about it? No, they have not spoken about it. So see, when one method establishes the statistical requirement, then need not go for some outdated or a old method of establishing uh, discount validity. So if you read this paper, they're very specific, and in let's say in one para they have addressed all issues related to measurement model. Yes, okay. And then they are talking about structural model evaluation. That is nothing but the path relationship between the constructs. Yes. And again here, see here, this is all convergent validity, construct, loading, and all this thing, Cronbach alpha. Yes. And this is the construct correlations that's a correlation matrix that they have presented. Oh, this is a discriminant validity estimate HTMT. They have only reported HTMT, not even this bootstrap HTMT. Fine, even you can report it when you are working with many constructs. And by the way, here if you focus IC, and IC is a influencer credibility, and it is a higher order construct, and it is having three other uh, first order constructs. In fact, IC is a reflective means lower order it is reflective, and first order also it is reflective. And they have reported and see none of the values are greater than 0.85. So they are saying that discount validity issue is resolved. By the way, you can simply read it here. Here you can read it. Uh, the construct items have, yeah, let me start from here. Let's see how they have reported it. The construct items have outer loadings of above 0.7, concluding the item's reliability. All the constructs extracted average variances are above 0.5. Yes, convergent validity is given. The HTMT ratio was used to examine and confirm the reflective construct discount validity because the HTMT values are below the conservative threshold 0.85 with respect to all the combinations of construct relations. The higher order construct IC was, and they have written it nicely. So you can just emulate this paper or paraphrase it and write your own analysis and understanding. Yes, okay. Then they have talked about higher order constructs. Yes, and this is how the reporting is done for higher order constructs and all. Okay. And then again, this is HTMT for higher order constructs separately they have done. And here you can see, all of you just pay attention, table number 5. Table number 5, RMSE, Q square predict. And whenever you see RMSE or PLS, SEM RMSE or LM RMSE, you should just understand this is nothing but establishing the predictive validity of the model. So let me read the line, my friends. Let me read the line. See here. The evaluation and comparison of the model's predictive power using the PLS SEM analysis and the neo linear model support the usage of PLS SEM. This straight away in the first line, they have jumped to the validity of the model. Normally, people talk about structural paths and all those things, R square and all. No, forget this straight away. The predictive power using the PLS SEM, and they found that usage of PLS SEM is supporting their results. Table 5 shows the results of PLS predict with 10 folds based on guidelines by Shumeli et al. By the way, this is the paper which you will cite whenever you are establishing the predictive relevance of the model and focusing on the model's key endogenous construct. So if you focus, which is the key endogenous construct of the model, see the key endogenous construct is purchase intention. So whenever you are establishing the predictive validity of the model, my friends, you need to focus on the model's main endogenous construct, that is purchase intention. It means, see, psychological ownership, attitude towards product, attitude towards advertising and social influencer. These are also endogenous construct, but they are not your main endogenous construct. Remember, your main endogenous construct happens to be purchase intention. So whenever you are evaluating the predictive validity of the model, you should focus on the main target endogenous construct, and it should be the final one where all the arrows are leading. So all the arrows are heading towards purchase intention. You can see there are 4 arrows towards purchase intention. So you should check the predictive validity of the model for the key endogenous construct. Yes, okay. And now here, let me come to this. So the results show that, let me read this paper for you. The construct indicators outperform the Lev linear model benchmark. It means, see, for predictive validity of the model, what this algorithm does, it calculates structure. It calculates structural paths using OLS method, and second, it calculates structural path using PLS method, and it compares PLS with LM. And if the PLS values are lower than the LM values, we say that the model has a decent predictive power. Okay, we'll see it. We'll see it in a very simple way. I think this is what they're talking about. And they're saying that Q square values are above 0. By the way, I think somebody was asking that, sir, seminar doesn't give Q square value. By the way, let's say if you are using, HTMT, then need not use Forner-Lercher. Similarly, PLS predict is more advanced, and Q square is bound to give errors. So Q square is not robust. So seminar package is not talking about Q square. They are talking about a higher model, or they're talking about higher method, beautiful method, or even a slightly better method than Q square predict. So your Q square values, if you focus on table 5, all your Q square values are greater than 0. So if your values are greater than 0, you say, okay, my model has some predictive power. So, but the best thing is use PLS predict. So when you use PLS predict, nobody is going to ask you, why haven't you gone and used Q square? Nobody will ask you. That will be a stupid question. It's like, MA किया है तो BA भी किया है क्या? When you said मैंने MA किया है, तो लोग बोलेंगे अच्छा BA भी किया है क्या? नहीं, MA किया है तो it's understood कि I'm graduate. So Q square is BA and PLS predict is MA. So when you say I've done MA, you need not explain that you are graduate. Yes, okay. So PLS predict. By the way, there is one movie by Paresh Rawal. He says मैंने MA किया है, बोलता है BA किया है कि नहीं किया? He's asking that question. So Q square is BA and PLS predict is MA. Maybe a stupid example, but it will relate with you. Okay. So now here, okay. So now again, this will not make you a lot of sense, but again, you should read this paper. Again, I'll suggest you, or just a second. First, let's see what's the logic. What's the logic? Again, this paper, 2019 paper, a very seminal paper, and has got a very huge citation. And here there is a separate section for establishing the predict. Here only assessing structural model. So first take all the R square and all those things and all. Okay. By the way, this paper also talks about. Let me use a different color or red color. Yes. Okay. So assessing structural model. Yes. Now, friends, please notice we focus on R square. Now, this paper says that R square is a measure of in-sample prediction. In-sample prediction means, see, actually they say R square has no significance. They are giving thresholds that if your R square is, let's say, between 0.25 to 0.5 or 0.5 to 6.5, what does it indicate? But they say R square is a matrix for in-sample prediction. For the given data set, you have given an R square. For different data set, your R square might change. So R square doesn't tell us much about the predictiveness of the model. So they discard R square. Then they talk about Q square. Now, what is Q square? What Q square will do? It will take your data and it will remove certain data points. Let's say you have a sample size of 250. So what Q square stats will do, it will delete every fifth item from your data set and replace it with the mean of the data set. And then it will calculate. So now people say, no, Q square is known as cross-validated technique. Again, that is not robust. So people say, okay, let's borrow the technique of assessing the predictive validity of the model from computer science discipline. So now in computer science, people divide their data into two parts. One is your training model, and second is your holdout model. So you estimate your model on the training sample, and then you estimate your then you perform the predictive validity of the model on your holdout sample. So actually, this dividing your sample into a training sample and a holdout sample actually is a discipline. Actually, is a technique which has been borrowed from the computer science in the PLS SEM algorithm. So PLS predict is a more robust technique of assessing the predictive validity of the model. They have spoken about R square and they say why R square is not, and they call it is an in-sample predictive power. It doesn't speak much about the predictive ability of the model for future observation. Let's say your model, somebody is testing by collecting a new data. Will your model be relevant? So that's why predictive validity of the model, it's also known as predictive relevance of the model. Is my model predictively relevant? Yeah, okay. So now here they talk about Q square value, stone geyser. By the way, seminar will not help you to calculate Q square value. If you want to calculate Q square, again, you should use CSEM package. CSEM package. So CSEM package will help you to calculate Q square, but Q square you can't get it in seminar. But check, can you calculate Q square by manual method? But according to me, Q square can't be calculated by manual method. There is no formula available for Q square because again, you have to remove certain data points from your original data, replace it by mean. Again, it's very complicated. So can't be handled by manual methods. So Q square can't be calculated by using manual methods. But CSEM is a package, yes, that can give you Q square values. But again, I'll tell you what is the defect of CSEM package later on. I'll tell you later on, not now. Otherwise, you'll get confused. So now, if you focus on this particular para, PLS predict. Here they are talking about PLS predict. Yes. Here let me use a yellow color. So the PLS predict procedure generates fold out samples based in PLS-SEM and is an option in PLS-SEM software such as Smart PLS. Now it's there everywhere. Yeah, and open source environments such as R. Yes. So here it talks about, if you read this line, it talks about PLS Predict executes K-fold cross validation. Now K-fold cross validation. A fold is the subgroup of the data and sample, and K is the number of subgroups. And let's say if you put K as 5, I'll show you. In fact, if I can talk about this, let's say this is your original sample size. Let's say this is your sample data set. Let me use a black color. Let's say this is your sample data set, and you gave the command to the software that generate me K equal to 5 folds. So it will divide your original sample into 5 times. 5. This one, this 5 equal parts. Your sample will be divided into 5 equal parts. So this sample will be hold out sample on which the predictive power of the model will be tested, and this will be your training sample. This will be your training sample. So when you keep K as 5, yes, okay. So something will be, so here if you focus here, so this in the diagonal, this will be your holdout sample. So let's say this is 5 is a 25. So 20 will be your training sample. 20 will be your training sample, and 5 will be your holdout sample. Holdout sample. Yes. Now you will estimate the model on the training sample and then perform the prediction on the holdout sample. So essentially that is the technique. And when you keep, let's say, and this will be repeated. Let's say now normally people keep K as 10 and then number of repetition also 10. So it uses certain iterative process and does this operation 10 times. So it will divide your sample into 10, and then 10 times it will within the system it will create this holdout sample and the training sample. That's an iterative process. Okay. So this paper, if you read it, talks about that only. It talks about that only. Yes. So now what we are going to do. Yes. So now we have tested a model, a parallel mediation model. Yes. And now we want to check whether is this model valid for future observation. Let's say if the same model is tested on new set of data, will it be valid? Now the function is PLS predict. The function is PLS predict. Okay. So if you simply type question mark and let's say predict underscore PLS, here you see you'll get the syntax. Question mark predict PLS, and here you get the syntax. The syntax is very simple. So predict PLS is the command. Just write the name of the model. Here you should write this model. You should write the model that you have estimated. Yes, estimated the model. And technique. Now, which are the techniques? So there are two techniques. One is your predict EA, and second is your predict DA. You should always use predict DA. You should always use predict DA. So predict EA, it means it will also factor mediation in the model. But authors have suggested that you should always go for predict DA, which this is more robust. Okay. And then this is number of folds. How many folds you want? 10. And how many times you want to repeat? 10. So number of folds means it will divide your sample into 10 different parts. And it will repeat the process 10 times. It will report the process 10 times and then segregate your sample into training and holdout sample. So all these issues are there. A simple one-line command. So now what I have done, friends, now I want to estimate that SIC purchase intention model, the parallel mediation model. I want to check its predictive power. So how to check it? See the command. Now this is a vector, predict underscore model. And to the left hand side, this is the function. And this is infer model estimate. Now let us check where is this infer model estimate. This infer model estimate let me check. Let me show you where it is. It is here. Step 3. So before bootstrapping your model, this is something that you need to capture it. Before bootstrapping, whatever the step 3, you need to just bring it here. Now there is always a confusion which vector to add here. So step 3 you should add here. That technique you should always, if there are mediators in the model, you should always use predict underscore DA. and this is by default. Number of folds 10, repetition equal to 10. This is by default. So now what I'll do, I'll simply run line number 114. Keep my cursor there and run it. Yes, okay. Now see, it is that this red blip is active. So it is doing 10 folds, 10 repetitions, dividing the sample into training sample, hold out sample, done very fast. Again, it's a R is so fast that it does. Now what I'll do, I'll simply this predict model, I will just summarize it and keep it in a vector called what triple X. Yes, okay. So now just let me run this. Okay. And if I see X, 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 see this is the predictive power of the model. Can you see? If I simply type, so just this predict the model and simply summarize it and keep it in vector, and you'll get this. Now, why I've created this vector triple X, I just want to show you certain things. Yes, okay. So now all of you just pay attention. Before I interpret this result, now let us now see what the authors are telling, my friends. All of you just pay attention. Huh? So let us go through this book that when to see if you see this, there are two measures. One is RMSE, that is root mean square error, and mean absolute error. So there are two metrics. Now the question is which one to see. The question is which one to see. Either RMSE or MAE. Any one you have to choose. Now the authors say if your errors are skewed, or if your or let's say if your errors are if your errors are normally distributed, then you should go for RMSE. But if you feel that if your errors are not normally distributed, then in that case you should go for MAE. But again, they have not used normally distributed term. Actually, there is a term which is specific. Here, if you see, just a second, just a second. Here you need to focus when interpreting can you see this? All of you can see this? Can you see all of you? Can you see this?
Yes, sir.
Yes, sir.
Okay, so when interpreting PLS predict results, the focus should be on the model's key endogenous construct. Means focus on the target construct, not on the mediator variables. When the key target construct has been selected, this is talking about Q square and all this. They are saying in most instances, researchers should use the RMSE. In majority of the case, you should RMSE. And in fact, if I show you this paper, A star, even what they have chosen, they have used RMSE. They have not even checked the logic whether your error distribution is symmetric or asymmetric. Yes, symmetric is the right word, not normal distribution. Because when I say normal distribution, there are tests available. And if you simply based your analysis simply on the looks, then looks are deceptive. A distribution might appear to be normal, but it might be otherwise, or vice versa. So this authors, this A star paper, they are simply by thumb rule, they have gone and checked the RMSE. But here they have given us a valid argument that when to use RMSE and when to use MAE. Now, for you, many of you who are want to intend to publish in good journals, I would also strongly suggest see the RMSE. See the RMSE. Yes, okay. So in most instances, researchers should use the RMSE. If the prediction error distribution is highly non-symmetric means it not resembling like a bell curve, then MAE is the more appropriate prediction statistics. Yes, okay. Now let me show you. Now again, this entire command line number 120 to 126, it is given by the authors. Now all of you friends pay attention. We always have to focus on the out of sample matrix, not in sample. Huh? This is in sample. See, this is in sample. This is PLS in sample results, and this is LM in sample results. You should least bother about in sample results, and you should focus only about out of sample results. Means you need to compare this matrix with this matrix. Focus on out, not on in. Again, I'm repeating, focus on out, not on in. That's why I've created this vector triple X, and later I'm extracting only out of sample for LM and out of sample for PLSF. And then I will compare this. But now let us understand whether my distribution is symmetric or not. So now let me run this command. If you focus on line number 120, this is PAR M for means I'm telling RStudio to create partitions in my plot window. So I'm telling give me 5 partitions. Why 5 partitions? because my dependent variable is PI, purchase intention. And you focus, there are 5 items to purchase intention. Now see, par M fro equal to C, comma, bracket 1, comma 5, bracket close. Why I'm writing 1, comma 5? Why I'm not writing 1, comma 10, 1, comma 20? Because see, there are only 5 indicators to my main endogenous construct, which happens to be purchase intention. So I will create 5 bifurcations into the plot window. So let me run line number 120, line number 120. And now you should see the distribution or see the symmetric distribution of all the items separately. So let me do it for P1. P1 happens to be the first manifest variable. So this, this, this. See what is happening in the plot window. I have created 5 partitions, so 5 things will come. And lastly, close it. Don't forget to close it. Otherwise, whenever you'll plot, it will become even smaller, or there will be issues. And R will show error, then you will get confused. So just close this one, line number 126. And now let me zoom it. See, now friends, if you see before you, there are 5 distributions of the prediction error: P1, P2, P3, P4, and it appears to be symmetric. Symmetric money, it appears to be symmetric. Yes. So when it is symmetric, then you should go for RMSE. And by the way, friends, you'll hardly come across papers where people have used MAE. Just check it on your own. You'll hardly come across papers where people have checked MAE. I think here there is a scope where one simply can't rely only on the pictorial description or pictorial visualization of certain distribution. By the way, a distribution might appear to be normal, but if you apply, let's say, Kolmogorov-Smirnov test, Lilliefors test, or for that matter, Shapiro-Wilk test, the test might say that the distribution is not normal. So when I always see this PLS predict, I always doubt diagrams, because looks are always deceptive, particularly in statistics. So I rarely trust diagrams. But as a thumb rule, I would suggest all of you use RMSE. Now, this vector XXX that I've created, I created it purposefully so that I can extract what I want, not what RStudio will give me. So if you simply type XXX, just a second, XXX, and if you put dollar, just take out of sample. First take out of PLS out of sample. Again type, go back dollar and take for the LM out of sample. Only out of sample, not in sample. Now compare. Now focus on the RMSE. Focus on these 5. Don't forget about PL, P2. Forget about first 5. See, compare P1 RMSE with LM out of sample. So first is 1.223 and this is what 1.216. Which one is greater? See, actually this should be smaller. If this is smaller than this, if all the items of purchase intention of PLS out of sample is smaller than this, we say our model has high prediction power. If let's say majority of the items in PLS out of sample are lower than LM out of sample, we say a sample has median prediction power. If all the items in PLS out of sample are greater than the LM out of sample, we say our model lacks prediction. Now let us see. Again, it is written. I will definitely read it for you for your better understanding. Compare this with this. So again, here we are losing. This one is greater. Compare with the second. This with this. Here we are winning. In 1.409, we are winning. Compare with 3, 1.420. Again, here we are losing. Compare 4, 1.244. Here we are winning. So 2 is winning, 4 is winning. 5 should win. Then only we'll say model has prediction power. See 5 is 1.297 and this is 1.270. So who is winning? Model lacks prediction power. Let me check. Am I correct? Let me check. Kya bol raha hai wo prediction? See, if the PLS analysis compared to the new LM benchmark yields higher prediction errors. So this should be higher. Sorry, I'm saying lower. This should be higher. This should be higher. Again, I said, how can we losing? I always make this confusion. Huh? Means this should be higher. This should be higher than this. So now you see we are winning. Actually, we are winning. We are winning in P1, we are winning in P3, and we are winning in P5 because we are higher. So see, here says if the PLS SEM analysis compared to the new LM benchmark yields higher prediction errors for all indicators. If all PLS SEM is higher, we say high prediction power. Second, if the majority of the dependent constructs, are higher. Now there are 5 indicators. Out of 5, 3 are higher. So, एक मिनट किधर गया इधर? No. Again, see, I'm goofing up. Let me read it properly. If the PLS SEM analysis, see, normally when I goof up, I simply look and read it. If the PLSS, if the PLSS compared to new element mark yields higher prediction errors in RMSE or MA all indicators, this indicates the model lacks predictive power. If all, no, again it's reverse. I made a mistake. Here always I commit mistake. So what it is says that if all the PLS SEM analysis gives higher prediction error, model lacks predictive power. Of course, not all are higher. Yes. Second, if the majority of the dependent construct indicators in the PLS SEM analysis produce higher prediction errors compared to the new LM benchmark, this indicates that the model has low predictive power. If majority of the analysis in PLS SEM out of sample, they give you a higher prediction error, we say low. And if minority of the indicators in the PLS SEM analysis yield higher prediction errors compared to the new LM benchmark, this indicates some medium predictive power. So if none of the indicators in the PLS SEM analysis has higher RMSEA values compared to the new LM benchmark, the model has high predictive power. Now, according to me, here you focus this P1 to P5. It is higher. It is higher than this particular thing for at least for 3. For 3 it is higher. Here it is higher. Then here it is higher. And, so we can say our model has low predictive power. Yes. Gopi Priyanka. Gopi Priyanka. Hello, Gopi. Are you there? Gopi, are you there? Okay. So now, what is the interpretation? That RMSE out of sample is higher for 3 constructs out of 5. Now we'll say that model has low predictive power. Now here you can't do and say, okay, let me manipulate and say model has high predictive power or medium predictive power. Simply go and report that model has low predictive power. That's it. Hope that this predictive power of the model is understood. Hello.
So it means, sir, PLS out of sample RMSE values are more than the LM out of samples RMSE. It means this what you have highlighted, these values should be more than these value highlighted values.
Yes.
Then this is the condition of low prediction or higher prediction.
Low prediction, sir. See, it is written here. Even I forget sometimes. Okay. See, focus.
Even language is little difficult, sir. Even I was
why.
going through.
Even many times, even in my previous workshop, I committed blunder. Then somebody said, no, sir. Okay. So in order to resolve this query, no, sir, just read this book, sir. This paper. Just a second. Human resource development, and they have explained very simply models prediction power. They have given an equation. So language is pretty confusing when I get confused. See, if PLS SEM prediction errors are lower than LM, lack of predictive power, means none of the items. So that this is not the case. This is not the case in our case. In fact, our errors are slightly greater. If PLS, this is saying that if again, let me give it some time. Sometimes when I forget, or so I simply take it. What it is saying that if the errors are greater, This is a greater than symbol. Yes. So if the errors are greater, we say lack predictive power. Of course, our all errors are not greater in PLSSE. So of course, our model doesn't lack predictive power. It has predictive power. Now here it says again for a minority of the indicators. Now here our errors are greater for minority of indicators. No. Here.
Sir, I think the first line says that LM, if the LM values are more than the PLS SEM prediction errors,
Yeah. Sorry. Greater than. You have
if
to
the
take it that way.
LM is more, it means it
Yes.
is a
Okay.
lack of prediction.
So LM is more.
I think, sir.
So if LM is more, so lack of predictive power. Our LM is more or what? Our LM is more. Just a second. Go slow. Our LM
Yes,
is
sir.
more. In fact, our LM is not more.
No, sir.
So of course, this is not the case. Go slow. Even I forget. Doesn't matter. Sometimes very confusing. Now next,
It
LM
means
for min.
according to our values, it means our prediction power is good.
Now focus on this. LM for a minority of the indicators is more. So LM for the minority of indicators is more. So here it is. So for 2 it is more. Yes. See, somehow we come here. LM for a majority of indicators. If it is more, yes. So I think we come here, and we say that model has medium predictive power. No, again, I'm slightly confused. Just give me some time. Just some time. Let me think it. Sometimes I read it and then reflect and then okay, because the language is slightly confusing here. Uh, Prediction errors are lesser than. See, actually, this see. First of all, to the left hand side means this error should be lesser. Please understand. Let me correct it. Your PLS SEM should be lesser for majority of constructs. Then only we can say that model has medium predictive power. If all your PLS SEM is lower, then we will say okay, model has high predictive power. But now if you focus, your PLS SEM result is more. Your error is more for three indicators. Then we will say model has low predictive power. This is a case of a low predictive power. Yes, and we fall somewhere here. Yes, we fall somewhere here. And again, if you can't make sense, then read this. If the PLS SEM analysis yields higher prediction errors, this indicates that model lacks predictive power. Error should not be high. If the majority of the dependent construct indicators in PLS SEM analysis, yes, produce higher prediction error, majority, this indicates model has low predictive power. This second one is applicable in our case, my friends. Now here you see, here out of 5, 3 are having more prediction errors. Then we will say a model has low predictive power, but still it has a predictive power. Now see, again, now here the question of Q-square reporting becomes very relevant. Now in most of the case, people will find that, okay, model has low predictive power and nobody likes low. See, even if it is medium, you can go and report it. So now what people do in order to get rid of this low prediction power, they report Q square, and they say, okay, Q square is there, it is above 0, so model has predictive power. Now you understood why people take defense of Q square, because somehow this PLS out of sample or LM out of sample, there will be certain issues with it. Okay, then people in order to justify, they say, okay, Q square is. And now let us read this paper, European wala, what they have said. Here it is saying that here the result shows that the construct indicators outperform the linear model benchmark as all the indicators show Q square predict values above 0. Now again, they have taken the defense of Q square. Furthermore, comparing the RMSE values yields lower prediction errors for all the PLS SEM. So this is lower. Can you see? PLS SEM should be lower. So this is 1.743 and this is 1.756. Again, this is lower. This is 1.945 and this is 1.98. Again, this is lower. Here also lower. So everywhere it is lower. So this PLS SEM out of sample should be lower. So here they have all the lowers, and that's why when they have minus this and this, they are getting in negative, and they say that their model has a high predictive power. Their model has high predictive power. Again, my friends, please note this. Now, if you use CSEM package, somehow I'm not convinced with CSEM package in a sense that CSEM package, whenever you will perform this PLS predict, it will give you a very perfect clear picture. It says that your PLS out of sample has lower errors. Your CSEM analysis tells that your PLS out of sample has lower errors. That's why of late I'm not trusting this PLS CSEM PLS predict analysis in CSEM. So when I compare this PLS predict analysis in CSEM and seminar package, I get a perfect picture in CSEM package. So there I slightly get skeptical. I said, no, I'm not trusting it. So, so and the seminar package is latest, so I go for seminar package. But here you see they are saying that all their RMSE errors are lower, and that's why their model has high predictive power. It's slightly confusing, but please note it that PLS SEM out of sample, yes, it should have lower error than LM out of sample for majority of the indicators. Then you can say high predictive power for all the indicators. For majority of the indicators, then medium, and if none, then low. If some low, if none, then no predictive power. There are 4 categories. Please bear this in mind.
So we can
Any
go
query?
for explanation without a Q square predict or not, sir?
See, first of all, here, even if the authors have not reported the Q square, it would have been fine because anyway, PLS predict is more robust. But again, people like to bring more analytical rigor into their paper. Yes, Lavji, people like to bring more analytical rigor. So people
Correct.
try reporting some. People say that okay, everything is saying that's high. Q square is also saying, and PLS predict is also saying. People love saying that. By the way, let me show you one more paper, Lavji, to answer your query. By the way, doubts are most welcome. And if I take this IMB paper, just a second. Where is that paper? Okay, just a second. Mm, just a second. It's not here. It will be there in my research. Take this IMB paper. It's a B category paper. A star paper we have seen, and now let us see the reporting in the B category paper, how they have reported it. Okay, and here they talk about this. Lavji, are you there? Yes.
Yes, sir.
All my friends, sorry, I'm forgetting many people's name because I'm not able to see that Zoom and all. I must identify everybody. So here it talks about predictive relevance, and they have simply used, sir, Stone Geezer Q square. So they say, in addition of R square and F square values, the present study also checked for Stone Geezer Q square value, which verifies the predictive relevance of the structural model. The blindfolding results indicate that the values of all the endogenous study variables are positive, greater than 0, and thus the structural model satisfactory predictive relevance. See how they took the defense, sir. My friends, can you see the defense?
Yes, sir.
They have not spoken about PLS predict. They have not spoken about PLS predict, and they have simply said, okay, Q square values are greater than 0. The model has satisfactory predictive relevance. Now, had they submitted this paper to A category, no, the reviewer would have asked report PLS predict results because Q square is not robust. Then there they would have said, okay, our model has low predictive relevance. See, naturally, when you take a very complex model, no, see, this is a very complex model. So when you take a complex model, no, definitely your RMSE of PLS out of sample, it slightly increases, and which makes your model less predictive. So people start reporting about Q square in defense of PLS predict, and they say okay, because nobody likes the low number though. It slightly doesn't go well with how you write and how you interpret. So that is one. But again, if you want to see one more paper, my friends, there is one more paper by again IMB review. I read a lot of IMB review paper because I like the quality of the analysis. And here also see they have spoken about Q square. And they are using the Smart PLS4. By the way, Smart PLS4 gives everything, but still they are very choosy about reporting. So quality of structural model. Here you see Again, they are silent about whether they have performed PLS predict or not. No, they are silent. They are reporting Q square. You see, Indian people are very smart in concealing and using a suboptimal method of reporting model predictive ability. By the way, I've also seen papers in C category where people stop up to structural model. Let me talk to you. If I take a C category paper, people stop up to structural model. They don't talk about predictive validity of the model. I've seen papers. They stop up to structural model. They say the path relationship are significant or not significant, and there they stop. And they don't report about Q square. They don't report about PLS predict. They stop. But higher the journal, better the journal. Again, you have to come out with interesting metrics. You have to take interesting metrics. And see, in the last session, that is day after tomorrow on Sunday, I will definitely be taking up CSEM package because there are certain functions which can't be model robustness checks. Actually, it can't be performed in seminar. In fact, the developers of seminar package, they have not talked about model robustness checks. I'm sure they must be thinking about it, and in times to come, they will definitely think of incorporating those model robustness checks in the seminar package. But as of now, they have not included those functions into the seminar package. But CSEM package, again, it is more robust. But I doubt the results of CSEM package, particularly with this PLS predict operation, because there you get a very clean picture that all the PLS out of sample are giving lower errors. So there I doubt. And when I compare with seminar, I see all relationship are same. Measurement model same, structural model same, but PLS predict seminar is saying that model has poor, the model is poor, and CSEM says model is high predictive power. Then there I slightly keep my fingers crossed. Then I start doubting CSEM because how can a model be so perfect and all the errors are lower? So that is a big question. And how this A star person has said that the model has a very high predictive power, taking 5-6 constructs, and maybe somebody might not have asked it because it's a very rigorous analysis, but uh, this is how it happens. Okay, any other query about PLS predict? Okay, by the way, who is this 8853449? Come on, unmute your can you change your name if you want? Okay. Shall we proceed now with moderation? Hello.
Yes,
Shall we?
sir.
Okay, let's proceed with moderation, and I'm getting exhausted today. Continue speaking now.
So you can take a break of 5 or 10 minutes.
No, today actually Shivratri is there, no? But let's talk about moderation. We'll at least see the theoretical underpinnings and we'll run a moderation model. Okay. So now friends, so far what we have done, come on. Measurement model, structural model, formative model, reflective model, then predictive power of the model. This is what we have tested. Yes. Okay. Now let's talk about moderation. Let's talk about moderation. Yes. Any random thought or any idea as to what moderation is? Hello.
Sir, the moderation is like any variable which affect the strength of the relationship between dependent and independent.
Okay.
Like
Strength. Okay. So let me
strength
put
of
it.
relationship.
So strength, and I would say sometimes it also affects the direction of the relationship.
Yes,
Just to
sir.
add to Sonam. Thank you, Sonam, for bringing out that. Otherwise, I would have forgotten this. So, moderation. See, mediation and moderation, please understand a new variable is coming. So, whenever, see, again, it's not coming on its own. Whenever you conceptualize that, okay, there is one variable which is going to, let's say, I'll give you an example. Let's say you are a hard-working person. Let's say this is the concept. A hard-working person will always give better performance. Yes or no? This is what logic and theory says. Yes, a hard-working person will give a better performance. But let's say if the organizational culture is vitiated, there is too much of politics. Yes, then ideally this relationship would have been positive. hardworking person would give better performance. This is a positive relationship. But because the organization culture is vitiated, because of which this relationship will become negative. Hardworking person gives a positive, gives a better performance. But since organizational culture is vitiated, this relationship is negative, and even a hardworking employee is not giving a good employee. Now, this is an example of a bad bossship. The boss is not good. Yes, on a very lighter note, I say, can you dismiss a boss? Hello, let me slightly deflect. Can you dismiss a boss? Hello, can you dismiss a boss? Let's say if you don't like a boss, can you dismiss the boss? Yes, Dr. Love will say is experienced person.
Impossible.
Yes. Huh?
Impossible, sir.
It's
The
possible.
boss can dismiss us, but
No, you can dismiss the boss from the post office bossship by putting your resignation.
Yes, sir, that's true.
You can dismiss the boss from the post office bossship by leaving the organization. You don't matter to me. I damn give you a care. तेरे जैसे कितने आए कितने गए ऐसे बाद में बोल सकते हैं. Yes.
Very true, sir.
So, by the way, this is not my dialogue. There is one movie by Kader Khan. And वो अपने बॉस से झगड़ा करता है, बोलता है तू क्या मुझे निकालेगा, मैं तुझे तेरे बॉसशिप से निकालता हूँ. I dismiss you from the post of your bossship. और वो रेजिग्नेशन मार देता है बॉस से झगड़ा करके. So वो डायलॉग मुझे बहुत अच्छा लगता है कि I dismiss you from the post of bossship, रिजाइन करके. तो आप बॉस को उसकी औकात याद दिला सकते हो नौकरी छोड़ के, बट फॉर दैट यू हैव टू पे बिग प्राइस इन द सेंस you should be really skillful to take your life ahead and go on without anybody's support. Yes, okay. So rightly said by Sonam that mediation and moderation, these are variables. In their presence, you are checking the relationship between the two variables. Now, moderation always answers the question when. Mediation answers how, moderation answers when. Yes, when the relationship will be stronger or when the relationship would change. So in the presence of moderate, now focus, now see, let's say, just a second. Hard working leads to performance. And let's say if the organization culture is good, so this relationship will become stronger. When I say strength or stronger, Sonam is correct. If hard working leads to performance and if organization culture is good, this relationship will become even more positive. So in the presence of moderator, the relationship will become either stronger or let's say if there's a negative moderator, the direction would change. A positive will become negative or negative will become positive. Now it can so happen if the organization culture is positive, a poor working person can also give a better performance. It can so happen. Yes. Now, all of you just pay attention, my friends. Something very important let us talk about. Now, please understand. Let me give an example. All of you just pay attention. Let's say X. Yes, people are busy. Now say X leads to Y. X leads to Y. And there is a moderator in the name of M. So sir, normally, yes, Felix, go ahead. Yes.
Please share the screen, sir.
Screen is not, oh my goodness. For how long it was not shared?
Just when you Shivaratri from Shivaratri.
Okay. Okay. See, friends. Okay. I wrote so many things. Let me erase this. Let me write it. Sorry. Thank you, Felix, for reminding. So we are discussing about moderation. Hope the screen is visible now. Yes. See, mediation and moderation, it is always tested when a new variable or when a new construct comes into picture. And I was saying that we all know that hard-working person will give a better performance. We all know this. If the person is hard-working, he will give better performance. But let's say if the organization culture is not good. Yes, now we know that hard-working person will give a positive performance. This relationship will be positive. But since organization culture is spoiled, because of this, now this person will give negative performance. So now we see OC, organization culture, is moderating the relationship between hardworking and performance. Okay. So we put it this way. So I think Sonam was talking about, see, moderation, what does it affect? it affects the strength of the relationship. It affects the strength of the relationship. And second, it affects the direction of the relationship. Direction means if positive becomes negative or negative become positive in the presence of the third variable. Strength means the effect will change. Yes, okay. And moderation always answers the question when. Means when will the relation be stronger or weaker? When will the relationship be stronger or weaker? Or weak? Yes, okay. So this is answered by moderation. Now, friends, all of you just pay attention. All of you just pay attention. Let me draw a diagram. Now, let's say x is my independent variable and y is my dependent variable. So x causes y, and there is one variable known as m. So normally in textbook you'll find such diagrams. Sometimes you find such diagram also. Yes. So moderator, normally this is the diagram. X leads to y, and this is the diagram of moderation. Now friends, how do you check for moderation? How do you check for moderation? So moderation, let's say y is my dependent variable. So beta naught plus x is my independent variable plus, and there is an interaction term. Interaction term means we check for b2 x into m and plus the error of the regression. So if this effect comes out to be significant, we say that there is a moderation. So moderation also, see whenever you are testing a moderation, you see the interaction of the moderator variable and the independent variable. So you create an interaction term. See, again I'm writing it. Moderation, it assesses the interaction effect. It assesses the interaction effect of what? Independent variable and the moderator. So moderator always assess the interaction term of independent variable and the moderator. Yes, okay. Now let's do one thing. Let's test moderation. By the way, I would suggest that let's keep moderation for tomorrow and not do moderation for today, because we are slightly ahead of our agenda. Because
Yes, sir.
can we
Sir,
see this?
by this time, sir, we can do the revision of what you taught us today.
So we can see here again. Again, I can actually today was this model comparison, all those things, but my syntax is there, but in some other file. I'll not. And here simple mediation and sequential mediation. I was supposed to teach you simple mediation, but it's simple and sequential mediation. Okay, and predictive relevance of the model, it's over. And this SRMR model fit indices, which Sonam was asking, it is there in PLS SEM but not in seminar package. This model fit indices can be taught using CSEM package. Okay, so this is the theory of moderation. So revision part, I'll simply just quickly sum up, and then what we'll do is that tomorrow let me use CSEM package and teach you now let's stop with the seminar package, and tomorrow let me use CSEM package and teach you all the model fit indices and model comparison and all those things. Okay. And by the way, model comparison can be done very easily, but let me not restrict it. Okay. So let's do one thing. Let's do one thing that but again, how many of you are interested in revising? Yes. There are a couple of questions. Kiran, go ahead. Yes. Let's take a question.
So can we not do model comparison in seminar package only?
Model comparison can be done in seminar package. Kiran, it's very easy. But here you have to conceptualize two model. In fact, that was my agenda, Kiran. Just a second. Model comparison can be done very easily. So now, Kiran, what we can do is that, no, here we can test a moderation model, Kiran. Okay, let me do it. Let me do it, Kiran. See, friends, let us test the moderation first. Yes, moderation always assesses the interaction effect between the independent variable and the moderator. So now let's say I conceptualize. Can you see this? So here I have conceptualized a model.
Sir, your
Where
screen is not visible.
screen is not visible. Just a
So you
second.
need to share this.
Yeah. Okay. Just a second. Friends, all of you pay attention. Line number, see this syntax I have not shared with you, but I'll definitely share with you. Okay, but tomorrow morning I'll share with you. Don't worry about that. Okay, so now let's check. Let's check moderation. Huh? See, now what I have done. Now here you can do model comparison, Kiran. Very easily you can do model comparison. Now, friends, all of you just pay attention. See, now what I have done, I have taken the earlier that SIC PI model. So what I'm saying, so there is one SIC. Social influencer connect. Am I able to connect with my influencer or not? I'm asking it using a formative measure construct. And SIC leads to purchase intention. So there is a direct effect. And now what I'm conceptualizing, if you see, I've created an interaction term in the name of PL, and I'm saying this pursued likeness. This pursued likeness will moderate the relationship of SIC and PI. Pursued likeness will moderate the relationship of SIC and PI. Now, can you tell me the equation? What will be my Y? My Y will be P1, PI equal to then beta naught plus, yes, okay. And then what will be my independent variable? Beta 1 will
Beta
be
1 SIC
SIC plus
plus
what will be my beta 2? PL, PL plus what will be my beta 3? This will be SIC into PL plus some error term. Okay. So now, friends, again, if this effect, this is the interaction effect. This is an interaction effect. Yes. If this somehow comes out to be significant, if this comes out to be significant, let's say if P is less than 0.05, then we can say yes, there is a moderation. So now let's test this particular model. Okay. So now how to test this model? Just focus here. Now friends, pay on line number, pay attention to line number 137. Now if you focus on line number 137, here if you focus, again everything is same. Now here I have created an interaction term. Just focus on line number 141. Everything remains the same, but here you have to add one interaction term. By the way, interaction term is a function, which is there in seminar package. And what is my IV? My IV is SIC. And what is my moderator? My moderator is PL. Just now you saw in the model specification. So I'll simply run this line number 137. Okay. Now after that, let me plot this. Let me see. Is it a moderation model? No, this is the measurement model. So here, if you focus on the measurement model, yes, it is saying that PI and PL are reflective and SIC is formative. No problem. This actually this is not required itself. Why to check the measurement model here? Now let's specify the structural model. Now structural model you have to be very careful. See, I've simply changed the syntax. I've simply written 1 and changed the vector. So structural model 1 relationship paths from to. So there are 3 paths now. See, now all of you friends pay attention. See, whenever you check for, see, this is a conceptual model. Now just pay attention. This model that you see, this is your hypothetical model. Now, how will the statistical model look? All of you just pay attention. How the statistical model will look. So there will be PI, yes, and there will be, so there will be one arrow from SIC to PI. Second arrow will be from PL to PI. And there is an interaction term. Interaction term means SIC multiplied by PL. Yes. So this. So this diagram that you see before you, this is your statistical diagram, or this is your statistical model. And this is your conceptual model. Conceptual model. Now, whenever you are writing syntax, you should always write syntax from the statistical model point of view. Now here you see, so there will be 3 arrows. So paths from SIC, PL and SIC into PL. This is the interaction term to purchase intention. So now select line number 145 and run it. And now here you can plot it. Here you can plot it. Here you use the plot function. See, are you getting a perfect diagram? Hello? 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 Hello?
Yes, sir.
Hello, sir.
Yes.
So here you are getting a perfect diagram. So one path from SIC to PI, PL to PI, and there is an interaction term SIC and PL. And if this path SIC and PI, SIC the product of SIC with PL, this third, if this is significant, we say that there is a moderation. Okay. Now let's estimate the model again. This remain the same. Okay. And let's summarize the model. Okay. And summary. Summary. Can you interpret summary? Yes. R square is the R square for the total model is 60%. This is adjusted R square. SIC to PI. SIC to PI is just the beta is 0.03. PL to PI. PL means perceived liking has a very strong effect on purchase intention. If you like the influencer, you're bound to purchase it. Yes. But social influencer connect. If you connect with the influencer, it is not necessary that you're going to buy it. Connection and liking, these are two different terms. And then this is the interaction term and all those stuff and all. Okay. And now let's do one thing. Let's bootstrap the model so that we can get confident interval and t value. So now let's bootstrap the model, line number 167. So its bootstrapping is running. So unless you get greater than symbol, you should hold on. Bootstrap is over. Then let's summarize the model. And simply copy this and Control C and Control V, enter, enter. Now here you can see, here you can focus. See this interaction term. See, first of all, bootstrap. This is not significant. Means SIC and purchase intention not significant. Perceived liking, purchase intention, yes, this is significant. And this interaction term, SIC into PL, again, this is not significant. But can you see this T stats? See, there is a dichotomy. Your T stat is significant. Your T stat is significant, but your confidence interval is not significant. You should always trust this bootstrap results. And you will say, no, there is no interaction term. Means in the presence of PL, even if you like your influencer, the liking will not moderate the relationship between SI and PI. At least the bootstrap results are suggesting this, because 0 lies between here. And rest other thing is there, you can just see it. Here also it is, there is a total effect that you can see. And the relationship is not significant. Okay. So what we will do is that, let's stop till moderation for today. Yes. And tomorrow what we can do is that tomorrow we will take a multi-group analysis and we will take model comparison, and we will also learn CVPAT, that is cross validated predictive ability test. Again, it is used for model comparison, and model comparison can be done using seminar, but CVPAT cross validated predictive ability test, it is not there in seminar. We have to still depend on CSEM. So tomorrow what we'll do, I'll take one model and test it using CSEM package. Is that clear? So it's almost like close to 9:10, and let us stop. And today is a fasting day. I'm utterly exhausted. By the way, let me take some queries. Let us take queries. Come on.
Sir,
Yes,
like,
Sonam, go ahead.
is it fine to go with the two packages? Like you said, okay, CVPAT, whatever it is, it cannot be done in seminar, but it is possible in CSEM.
Now,
And
listen. See, a model comparison can be done using seminar package also. People see one indices which is known as Bayesian information criteria and Akaike based Bayesian information criteria. But let's say, see, first of all, to answer you, can you go for two models and two packages? I don't have a crystal clear answer for this because I don't know how reviewers might take it. But if you are writing a PhD thesis, Sonam, it's perfectly fine. Use multiply every model. See, results are same. Results are same. But of late, I don't know whether how you will hardly find that people are using PLS SEM in at least for journals. At least I have not come across bearing this well-known names like Hare and Sarsted and Ringle and all. So let's say if you use two packages, might be the reviewers how they react. I have no idea on it. I have no idea on it. But according to me, any package, or for that matter, any software which is helping you to analyze and give numbers, for me there is no harm. For me there is no harm. But CVPAT, it is there in CSEM. So see what the purpose of this workshop is. By the way, my papers are getting rejected, and I'm not sure is it rejected because of R. Because I'll tell you, I submitted my paper to employee relations. First, I submitted to BAPS. They rejected it, citing poor mediation. And Bootstrap, he didn't even give me opportunity to defend also. Straight away rejected. After 43 days, that's rejected. Second, I submitted to employee relations. They say, your paper, our paper doesn't fit into our scope. Employee relations. It's a B category, all a B category. So they recommended 3 papers: Journal of Managerial Psychology and Industrial Journal of Organizational Analysis, and third is Journal of Organizational Effectiveness, People and Performance, so on. So I send it to, after employee relation, I send it to JMP. They said your research methodology doesn't fit into our scope. They rejected it. Third, I sent it to International Journal of Organizational Analysis. They rejected, saying that we don't have time to respond to what are the mistakes, but your paper is rejected. Itna hi bol diya. So I'm still clueless. Are they rejecting because of R? Now I've started doubting it. So now simply what you can do, simply instead of saying R, simply say I've done all my analysis in Smart PLS4. But God knows. But Sonam, to answer you, it's for my understanding says that software is just a tool, and you can use combination of packages. But I don't know how the reviewers are going to react it. I don't know, because many people are not well versed with all those things. And even you see this A-star paper, they are using Smart PLS 3 and 4. So I can't comment.
Sir, option is this, like you have submitted to some journals, and from this group only some people can collaborate and write some papers, and they can send it to some other journals. We can we can wait for their reviews, either they are accepting or not.
See, actually, they don't see. First of all, in my understanding, no sensible person should simply reject it, citing that you have used R. Now there will be other issues. This is what I feel, and I'm fine tuning that paper, and now I'll send it very soon to. Once this workshop get over, I'll definitely send it to some good journal now. That same third journal which is remaining it. So nothing harm in that. Few people can collaborate and write it. Nothing harm with it.
Sir, another question is this: can we perform mediated moderation and moderated mediation models?
Yes. All conditional. You are asking conditional process analysis. Yes. Conditional process analysis or mediated moderator or moderated mediation is a conditional process. It can be performed in CSEM. Yes.
The
Only
conditional analysis is NCA, that is necessary conditional, या वो कुछ अलग होता है NCA
नहीं NC आप मुझे आप बता रहे हो कि मॉडरेटेड मीडिएशन या मीडिएटेड मॉडरेशन की बात कर रहे हो ना. सो ये नॉर्मली वो प्रोसेस मैक्रो के अंदर सब आ जाता है, वो प्रोफेसर हेस का.
अच्छा.
सीसेम पैकेज का इतना अच्छा खूबी है ना, जैसे इपमा है, इंपॉर्टेंस परफॉर्मेंस मैप एनालिसिस, सीसेम कर लेता है, सेमिनार नहीं कर पाएगा. बट नेसेसरी कंडीशन एनालिसिस मैंने अभी तक एक्सप्लोर नहीं किया है सोनम, और इसके लिए मैंने एनसी अभी इसमें पार्ट में रखा नहीं है, मैंने वर्कशॉप के स्कोप में रखा नहीं है.
बट mediated moderation and moderated mediation can be done in seminar, no?
Yeah, it can be done. It can be done.
Okay. Thank you so much.
Yeah. Okay. Any other query? Any other query? So, see, the purpose of this workshop was to make you keep you on your own toes. Yes, and so that you go use R for your research and publish good papers. Collaboration is open. We can definitely collaborate, and we can decide our contribution, that what part we will take and what part we will not take. Yes, okay. So today is Shivratri, and I'll just winding up the session 15 minutes before, because I'm exhausted and
So
I can't.
happy Shivratri. Sorry
Happy
for
Shivratri,
waiting. Happy
No, it's okay.
Shivratri to everyone.
Yeah. Same too. So should we call the session, everyone? Yes. Keep your doubts, and we'll definitely take it in the next session. Yes. Okay.
Yes, sir. Collaboration, sir. I'm always ready. Anyone want to collaborate, sir? I can give my up to my extent.
See, this WhatsApp. I'll tell you, the beauty of the WhatsApp group is always remain intact. I think hardly people will leave it, but let's keep this WhatsApp group intact.
What Sonamji was saying, sir, I truly agree. And if the group is ready, sir, we can contribute to something extraordinary, sir.
Yeah. 5, 6 of us can write a paper. 5, 6 of us can write a paper, but provided there has to be bonding, and virtually when we are meeting, we have to set ground rules that every Saturday we'll meet, or every Monday we'll meet. We'll track our progress, and everybody should be on our own. Should complete their formalities.
Correct,
Definitely,
sir.
collaboration can be done. Yes. Okay, bye. I'll upload the recording very soon for you. So have a great day. Have a nice day. Happy Shivratri, all of you. Bye.
Thank you so much, sir. Same to you.
Thank you, sir.